This is Apollo Control Houston at 43 hours, 32 minutes now into the flight of Apollo 14. We show the spacecraft presently 147,372 nautical miles out into space and traveling at a speed of 3,442 feet per second. We've had no contact with the crew of Apollo 14 since our last report. Spacecraft Commander Al Shepard, Stu Rusa, and Ed Mitchell now into their rest period. Our flight surgeon is presently monitoring data on Spacecraft Commander Al Shepard. His data indicates that Shepard is relaxing, but probably not yet asleep. At this time, we will take our live air-ground line down and bring it back up should we have contact with Apollo 14. We're at 43 hours, 33 minutes into the flight, and this is Apollo Control Houston. This is Apollo Control Houston at 44 hours, 32 minutes now into the flight. Apollo 14 is presently 149,338 nautical miles out from Earth. Its velocity now reading 3,384.9 feet per second. We've had no communication with the crew since our last report. The crew of Apollo 14 now well into their rest period. Our clock in mission control shows 6 hours and 27 minutes remaining until time of wake up. Meanwhile, the surgeon is following data on Spacecraft Commander Al Shepard. He reports that Shepard entered into a sound sleep at 43 hours, 43 minutes ground elapsed time. We're at 44 hours, 33 minutes into the flight, and this is Apollo Control Houston. This is Apollo Control Houston at 45 hours, 32 minutes now into the mission. Apollo 14 is now at a distance of 151,272 nautical miles away from the Earth. It's now traveling at a speed of 3,329 feet per second. We've had no communications with the crew since our last report. The crew now well into its rest period, into their rest period. One of our countdown clocks in the control center shows a wake-up time of 5 hours and 27 minutes from this time. So at 45 hours, 33 minutes, continuing to monitor, this is Apollo Control Houston. This is Apollo Control Houston at 46 hours, 22 minutes into the mission. We now show Apollo 14 at 152,854 nautical miles away from Earth. And its present velocity, 3,283 feet per second. Our clock in mission control shows 4 hours, 37 minutes remaining on the rest period of the Apollo 14 crew. We would also like to repeat at this time an earlier announcement. The modular space station news briefing is scheduled to begin in about 5 minutes at 1:30 p.m. That's 5 minutes at 1:30 p.m. in the News Center briefing room. At 46 hours, 23 minutes, this is Apollo Control Houston. This is Apollo Control Houston at 47 hours, 32 minutes now into the flight of Apollo 14. Our displays presently show Apollo 14 at a distance of 155,040 nautical miles away from the Earth. and traveling at a velocity of 3,200 at 21.6 feet per second. Presently in mission control, one of our bottom clocks is counting down to the time of the GMT liftoff update. The clock presently reads 6 hours 57 minutes, counting down toward the GET of 54 hours 30 minutes. One change in the flight plan, and that concerns the housekeeping in the lunar module. This will be done in the PTC, or passive thermal control mode, to conserve on RCS propellants. This scheduled for 61 hours 45 minutes comes after the clock update. However, the ground elapsed time will remain exactly as that's shown in the flight time, and the Central Standard Time will remain essentially unchanged. It's been a very quiet day over the flight director's loop. The individual flight controllers monitoring their systems, talking to their back rooms, really having very little to say of widespread interest. We're at 47 hours, 34 minutes into the flight, and this is Apollo Control, Houston. This is Apollo Control, Houston, at 48 hours, 22 minutes, now into the flight of Apollo 14. We presently show Apollo 14 at a distance of 156,579 nautical miles away from Earth, traveling at a speed of 3,178 feet per second. Meanwhile, in mission control over the past 20 to 30 minutes, Flight Director Pete Frank has been discussing with his flight control team procedures for Al Shepard and Ed Mitchell's Lunar Module housekeeping chore scheduled for early tomorrow morning, and flight plan changes are emerging. Since there will be no mid-course correction 3 scheduled, the current outlook is to move the LIM housekeeping forward by 1 hour, moving forward to 61 hours 20 minutes ground elapsed time from the previously scheduled 62 hours 20 minutes. This would also move the television time forward by 1 hour, moving to 60 hours 40 minutes ground elapsed time from the previously scheduled 61 hours 45 minutes ground elapsed time. Honeysuckle will be the station for this transmission. Considered into the changes is a revision back to the original flight plan, whereby we would not continue with PTC, or the passive thermal control mode. The consideration given here was that a wastewater dump will have to be scheduled in any case, and the procedure to be followed would be to schedule this dump as close as possible to the television and the housekeeping. The advantage to moving forward by 1 hour is to put the LIM housekeeping activities all on one shift. The previous planning or scheduling would have a shift change with about 1 hour remaining into the activity. Also, moments ago, the flight dynamics officer has passed along a new set of updates for S-IVB impact. The coordinates now read 88 degrees, 40 minutes south, 26 degrees, 19 minutes west, at a ground elapsed time of 82 hours, 38 minutes, 3 seconds. Uniquely, the spacecraft, Apollo 14, will be passing over the front side of the moon at the time of impact. This was not the case in Apollo 12. It should be passing over the longitude of 61 degrees east at time of impact along its flight path. This would place it about 30 minutes away from passing over the longitude of impact. We will shortly be changing shifts here in the Mission Control Center, with the maroon team coming in to replace the orange team of flight controllers. The orange flight control team took over this morning shortly before the crew entered its rest period, and we have not heard from them aside from the first 15 or 20 minutes of our shift. We're at 48 hours, 26 minutes into the flight, and this is Apollo Control Houston. This is Apollo Control Houston at 48 hours, 39 minutes into the flight. We now show Apollo 14 at an altitude of 157,109 nautical miles, a velocity of 3,163 feet per second. We will repeat an earlier announcement, that being that we do have a flight plan change emerging. Since there will be no mid-course correction 3, the current plan in Mission Control is to move the Lunar Module Housekeeping forward 1 hour. This would move that time forward to 61 hours, 20 minutes ground elapsed time. By the same token, this would also move the television transmission time forward 1 hour, moving to 60 hours, 45 minutes ground elapsed time. The Honeysuckle station would be the station having acquisition. Further, the decision has been made not to continue in the passive thermal control mode during the Lunar Module Housekeeping period. This decision being made since there is a requirement to have a wastewater dump, and the present plan or outlook is to move the wastewater dump to a time close to the Lunar Module Housekeeping. There's an advantage to moving forward the housekeeping 1 hour, this advantage being that all of the activity will take place with one shift of flight controllers. We're at 48 hours, 41 minutes into the flight, and in Mission Control we're in the process of a handover from the orange to the maroon team of flight controllers. Since the Apollo 14 crew, Al Shepard, Stu Rusa, and Ed Mitchell, were asleep for the entire shift, there will be no change of shift briefing scheduled. This is Apollo Control Houston.
This is Apollo Control at 49 hours, 32 minutes. At this time in Mission Control, the Maroon team, headed by Flight Director Milton Wendler, has completed its briefing. Each of the flight controllers reviewed the status of the mission and the spacecraft with the Flight Director. And we find everything progressing smoothly at this time. No problems with the spacecraft. The surgeon reports that all the crewmen are healthy. And at this time in the sleep period, they have all gotten at least 6 good hours of sleep. The sleep period is scheduled to last for another hour and 27 minutes. Some of the telemetry data would indicate that there has been some stirring around in the spacecraft, but at the present time, all 3 crewmen would appear to be sleeping or at least resting. Coming up on this shift, among the activities, is the clock update. This is scheduled to occur in the flight plan at about 54 hours, 45 minutes ground elapsed time. Flight Director Milt Wendler advises us that won't be an event that will occur at any precise instant, but will probably require a total of about 10 minutes to sync all of the clocks together at the updated time. But at about 54 hours, 45 minutes, we would plan to jump ahead in ground elapsed time to about 55 hours, 25 minutes. The exact amount of time to be changed will depend on assessments as to the need for mid-course correction 4, but the variation would be very slight, a matter of seconds. At the present time, the Flight Dynamics Officer reports that mid-course correction 4, if it is needed at all, would appear to be around 2 feet per second. The additional tracking data shows the parasynthion to be coming closer to the preferred 60 nautical miles. We're presently showing it at 65. When the initial tracking came in yesterday following the mid-course correction maneuver, the data showed that the parasynthion was about 67 nautical miles, and as expected and as we've seen on previous missions, additional tracking tends to confirm that the parasynthion is in fact lower than the initial tracking shows. At the present time, we show Apollo 14 traveling at a velocity of 3,117 feet per second, and the spacecraft altitude right now is 158,778 nautical miles. We'll continue to stand by and come up as soon as we hear any conversation from the crew. As I said, the sleep period is scheduled to end in about 1 hour, 25 minutes from now. At 49 hours, 35 minutes, this is Apollo Control, Houston. This is Apollo Control at 50 hours, 32 minutes. And at the present time, we're awaiting the crew's awakening. The crew is scheduled to awake from this sleep period at 27 hours, or rather 27 minutes, 45 seconds. And the last check with the surgeon, we hadn't seen any indication that the crew was stirring at this time. During part of the period of time since our last announcement, we've been on low bit rate data and have not had heart rates from the crew, which of course is the primary indication as to whether or not they're sleeping or beginning to stir. At this time, Apollo 14 is 160,493 nautical miles from Earth, and the spacecraft velocity 3,069 feet per second. This will be a relatively quiet shift as planned in the flight plan. Coming up, we have the clock update, which will occur at about 54 hours, 45 minutes. They'll be running some checks on the S-band communications equipment and the VHF system in preparation for the Bistatic radar test to be performed later in the mission. And they'll be changing lithium hydroxide, one of the lithium hydroxide canisters in the command module. There's also a crew exercise period scheduled at about 57 hours. That would be using the in-flight exerciser, which is an isometric, isotonic type device. we'll be standing by for the crew to awake, and as soon as we get any conversation with the spacecraft, we'll come up again and begin covering the air-to-ground live at that time. At 50 hours, 34 minutes, this is Apollo Control, Houston. This is Apollo Control at 50 hours, 54 minutes. We just received a call from Al Shepard, so we'll pick up and follow any conversations live from this point on.
Houston, Apollo 14. Houston, Apollo 14.
Apollo 14, this is Houston, go ahead.
Good morning, Bruce. Reading you loud and clear. We have completed our post-sleep checklist. We have the radios for you when you're ready to copy.
Roger, go ahead with the post-sleep checklist.
Okay, the checklist is complete. We have the following readings at dosimeter. Cal 16041, slept 5 hours. 201038, slept 7 hours.
Okay, 14, understand Al 16041 and 5 hours. Stu 01038, 7 hours. Ed 05038, 6.5 hours, over.
That's correct.
Apollo 14, this is Houston.
Good morning, Bruce. Go ahead.
Roger, I don't want to interrupt your eat period, but when you have a convenient time, I have a plan update for you. It's a fairly lengthy one. Nothing in the immediate future, though.
Okay, stand by. Roger, stand by for about 5 minutes or so, and be advised we completed the LIO canister change at 51 hours, and the LIM command module Delta P at 5059 was 0.95.
Understand 0.905 for the Delta P at 5059.
Confirm. Hey, Bruce, I'll take that flight plan update. Press ahead.
Okay, Stu, here we go. You may want to just get out the flight plan and mark out the items as we go along, or you can copy it down, either way.
No, I'd rather work on the flight plan. You give me the right places to go.
Okay, up through 5920, that's 59er plus 20. Everything is nominal. And from there on, you take the LEM CM Delta P vent at 59 hours and 25 minutes and move that up to 59 hours even.
Okay, we'll move the LEM command module Delta P VIN up to 59 even.
Roger. Take the P52 that occurs at 59:45 and move it up 10 minutes to commence at 59:35. Over.
Okay, we'll shoot a P52 at 59:35.
Roger. At 60 hours and 20 minutes, you have an O2 fuel cell purge and a wastewater dump listed. We want to move those up to 59 hours and 50 minutes. That's 59er plus 50. You still with me, Stu?
Okay, Bruce, I moved the fuel cell purge. Yeah, I'm just getting it all in here, Bruce. Move the fuel cell purge and the wastewater dump to 5950.
Roger. Delete mid-course correction number 3, over.
Jolly good. We'll strike out mid-course 3.
Okay, now everything's scheduled between the times of 60 plus 55 and 64 plus 10 should be scheduled 1 hour earlier. And if you look at 64 plus 10, the break point there comes after the verb 48, and we're going to have a write-in that says establish PTC there at 6310, and the LIOH canister change comes at the nominal 6412. Over.
Okay, let's run over this one again then. Everything from 61 hours to 6410 is moved up an hour. Is that affirmative?
Roger, starting with the prepare transfer items per LEM activation checklist and all that stuff.
Okay, we'll move that up 1 hour. Okay, I've got that. Everything from 61 to 6410, move up an hour.
Roger, stand by a second. Roger, Stu. At the time of 6310, following the LEM housekeeping activities, reestablish PTC. Over.
Okay, we're going to PTC at 6310.
And perform the lithium hydroxide canister change at the nominal currently scheduled time of 6412, and pick up the normal flight plan timing and sequence afterwards. Over.
Okay, we'll change the canister at 6412 on time, and then be back on the flight plan.
Roger. And I have a 51-hour consumables update for you if you're ready to copy back at 51 hours.
Stand by one. Okay, let her rip, Bruce.
How do you read me, Stu? I think we're in the process of changing antennas.
I read you 5 square. I'm ready to copy.
Okay, GET of 51 hours even. RCS total 84%. Alpha 84. Bravo 83. Charlie 84. Delta 84. H2 tank 1 79er decimal 3. 79er decimal 7. O2 tanks 9er 2. 9er 1. 4-5, over.
Okay, got you at 51 hours, total 84. Alpha 84, Bravo 83, Charlie 84, Dog 84, H2 79.3, 79.7, O2 92, 91, and 45.
Roger, and you may be interested in knowing that at the present time you are only 20 pounds of RCS fuel below the nominal, so you're really gaining on it there.
I'm sorry, Bruce, you busted up. Would you start over again, please?
Roger, with respect to total RCS fuel, you are only 20 pounds below the planned RCS budget at the present time, and you are
Okay, that's broken up pretty badly. I did read we're 20 pounds below now.
Okay, Stu, how do you read now?
Okay, I'm back with you, and I copied the 20 pounds.
Roger, and that's really closing in on the nominal there. A couple of other items that came up while you were asleep is that we're going to go ahead and exit PTC for the LEM housekeeping since we want to have the TV up for it, and we're just going to go ahead and dump the wastewater anyway, or run that by again. We need to dump the wastewater, which will ruin PTC. Consequently, we're going to come out of PTC for the LEM housekeeping and have a good TV attitude to boot. One item is that I believe you went to sleep with 1620 showing on the disky, which was continuously updating during your sleep period. And unless you have strong feelings otherwise, we would rather have a blank display up on the disky to keep from cycling the little read switches all the time. And another flight plan item at 55 hours even or thereabouts, we intend to request another set of photographs of the S-4B from you using the data acquisition camera and the sextant. We'll have an updated Noun 88 for you later on. Over.
Okay, and say that time again, Bruce.
Roger, 55 plus 00. Over.
Okay, and we'll blank the disky.
Okay, no need to blank it
For
down.
sleep, that is.
Roger.
No, I understand. For sleep, we'll put it to rest.
Roger, roger. And when you all get your breakfast well prepared and are feeling in a jovial mood up there, why, we'll proceed with the Bruce and Bo show on the morning news.
Okay, hang on till we all get tuned in. We sure wouldn't want to miss that.
Now, it'll be a couple of minutes yet. We just got the paper here and we're editing it right now.
Okay. Bruce, I was thinking about that, I could see through the sextant. You know, I had looked like two dim stars in the sextant at that pointing attitude, and I didn't see any tumbling motion at all on either one of them, and they were separated probably by roughly half to 3/4 of a degree. I'd say 0.5 to 0.6 of a degree separation between the two. But I really couldn't see anything that would determine whether I was looking at the S-4B or a star, faint star.
Roger, we copy, Stu.
I really expected this. I guess I really expected the S-4B to be a little brighter than either one of the two objects that I looked at.
Okay, stand by a second, please. L14 Houston, Stu.
Go ahead.
Yeah, we've just received the intelligence down here that your family is having lasagna for your breakfast. Over.
Oh man, that's good timing.
I thought you'd enjoy hearing about it.
There's nothing better for breakfast than lasagna unless it's a sausage onion sandwich.
Very good.
Houston, Apollo 14.
Go ahead, 14.
Roger, Bruce. I have a few observations about the light flash experiment that I'd like to pass on, and perhaps you can generate some information from it that might be useful to us.
Would you stand by a minute, please, Ed?
Okay, standing by.
Apollo 14, this is Houston. Ed, go ahead with your commentary on the cosmic ray light flashes, and we'll digest what you've got and give you our views back probably in a couple hours. Over.
Okay, Bruce. First of all, let me say we all decided to try to dark adapt and run the experiment, or at least part of it, last night. I think our experience was that we probably saw one flash after dark adapting and promptly fell asleep before we saw any more. At least that's true in my case. I think Al and Stu stayed awake a bit longer. However, I think we have seen only 3 types of flashes so far. What we would probably call a star, a supernova, and a flash, or rather in a streak. And I think that I have seen some, don't recall what name we tagged to them, but reminiscent of the lightning flashing in or behind the clouds. Those are the only ones that we have really identified, and it takes a while to realize what you are seeing because it happens so quickly that it takes a little bit of practice before you can really recognize these things. I think perhaps after watching them for another period or so, we will be a little more experienced at it and be able to do a more creditable job of dark adapting and getting the sort of data that would be liked. My experience is that even the so-called star, the supernova, are not as clean a phenomena or clear a picture as I had in my mind that they would appear. There still seem to be at least 2 flashes, maybe a bright flash followed an instant later by a more subdued flash, or perhaps a halo-like effect. It doesn't seem to be, there does not seem to be a set pattern in each case. Sometimes it's a very clear single flash, sometimes it seems followed by a halo, sometimes it seems followed by an adjacent flash. I guess that's about all I have to say at the moment.
Roger, Ed. I think we copied all that.
I'd like to add a few comments on that too, Bruce.
Go ahead.
Hey, Bruce, do you read?
Roger, 14, go.
Okay, Bruce, I'd like to make, you asked yesterday about whether we saw them before we were dark adapted, so last night I took my flashlight and shined it in both my eyes, and of course, that should run any dark adaptation you would have, and in fact, you got the residual glow in your eye for a minute, and then closed them, and in one case, less than a minute, I had started seeing the flashes, and on the second time around, I'd say it's probably around 2 minutes before I start picking them up.
Okay, Stu, and were you seeing, when you started seeing him, did you see a number of flashes? Ed reported, I think he saw just about one before he fell asleep.
Well, what we did was we set the timer on 20 minutes, and I heard the timer go off, and by that time I had only seen 4 or 5 flashes that I could recall. However, at some other periods during the night, that isn't when I did the flashlight routine, that was later on, more toward this morning, when I started playing with the flashlight, and in one case I saw one, and then followed not too long after that by 4 or 5, and then haven't really picked up any pattern on that. You may see one, and then 3 or 4, you may see one, wait a while. Can't really, it's a little difficult to time in the dark, and get a feel. And as far as the types of...
Okay, we're switching antennas, Stu.
3 types. However, my supernovas, the explosion is just in one. It's very rare I'll see a discrete pinpoint of light for a minute. And then the streaks I've noticed are all what I would consider over at the periphery of my vision. It appears that almost all the streaks are right along the edge of my eye, and I get the impression that the majority of these I run and say longitudinal with the axis of my body, and it seems rare that I see a streak that's right in the center of my vision.
This is Ed. I have had a little different experience than Stu has. I don't think I have seen quite as many streaks as he seems to, but I have seen some that appear to be going from right to left, near the center of the field of vision. However, I have mostly been concentrating on trying to identify the types as opposed to locating them and getting their frequency. I did observe one right after we started to dark adapt, about 20 seconds, but nothing after that. As I say, I think I fell asleep sometime within a couple of minutes after that.
Do we have any observations from the commander?
He's busy cooking breakfast right now.
All right, Roger. And I guess we just went through an antenna switch over, and we've got some news here if you all are ready.
I have only one comment, I think, to echo the other from the light flashes. They do seem to be random, sort of a showery type pattern. They are visible in a darkened cabin within a very few minutes after turning the lights out, perhaps as small a time as 1 or 2 minutes. And as far as the characteristics of flashes are concerned, I've observed about what the other guys have.
Roger, we copy, Al. Oh, 14 Houston, are you interested in some news?
Roger, press on.
Okay, from the sports world, Marquette's streaking Warriors continued to hold forth as the nation's top-ranked college basketball power Monday, while unbeaten Southern California displaced defending champion UCLA in the runner-up spot. Houston, 15-3, is a newcomer to the top 20. The Cougars, who play Long Island U in Madison Square Garden Thursday night, moved into the number 18 spot. USC and UCLA will collide Saturday at Southern Cal. It's too bad we don't have a TV uplink for you.
It'd be pretty nice.
14, this is Bo Bobko. How do you read?
Good morning, Bo. Loud and clear. How are you?
Just fine, sir. This is Washington Associated Press. The Food and Drug Administration said tests on compressed fish products, such as frozen dinners, fish sticks, and fish cakes, show mercury content well below the danger level. The FDA said Monday more than 80 samples contained an average mercury level of 0.06 parts per million. Under FDA guidelines, fish with a half part per million is withdrawn from the market.
Seems reasonable to me.
The chill blast of a February norther blew into Texas Monday, dropping the temperature sharply after the summer-like weather which closed out last week. January's last day saw temperatures in the 90s at several points in deep South Texas. And it was one of the driest months ever back here in Houston. Here in Texas, the Dallas Weather Station, for example, measured 0.16, that's 16/100ths of an inch of rain, against the normal 2.32 inches for January.
The rarest atom particle reported found. New York, Associated Press. Physicists from the University of California reported Monday they have discovered the rarest and most elusive of the nuclear particles within the atom. They found the particle's track on a photograph of a nuclear interaction, an inch-long footprint it left during its brief lifetime of 15 billionths of a second. The particle is called the anti-mega-minus baryon antiparticle, the mirror image of matter as we know it on Earth. The discovery is related to the idea that somewhere out there in space there are galaxies made up of antimatter, just as galaxies or star clusters, such as the one we live in, the Milky Way, is made of matter.
Hey, Bo, I think I saw one of those just go by the window.
Grab it quick.
Hey, Stu,
Bo, how long did they say the track was that it... Bo, how long did they say the track was that they had seen?
An inch-long footprint it left during its brief lifetime of 15 billionths of a second. They said, we had a standing offer of a case of champagne to whoever found it, Goldhaber said. When I get back to the lab, I have to deliver.
do you think Stu qualifies for one also?
All right, let it get away, Bruce.
Hey, that's a pretty great piece of news.
Okay, on Wall Street, investors bought heavily on Monday, giving the Dow Jones Industrial Average its highest single-day gain of the year. The Dow Jones average of 30 industrial stocks closed up at 877.81, up 9.31 points for the biggest one-day jump in 71. Trading was heavy throughout the session, with the New York Stock Exchange ticker backed up a minute or more several times during the day. The tape was 3 minutes late at the close.
Washington, UPI, the administration is considering a pollution tax, such as a levy on emissions of air-polluting sulfur dioxides, in an effort to give industry an incentive to clean up, President Nixon's economic report said Monday. The report, prepared by the President's Council of Economic Advisors and sent to Congress under Mr. Nixon's signature, said a tax may be a more effective way to control pollution than direct government regulation.
At 9:03 tonight, the Apollo 14 crew will begin operating under NASA's own version of daylight savings time. The readjustment of the mission clocks will bring the flight back to the actual real time, parenthesis, Greenwich Mean Time, parenthesis, for activities as scheduled in the flight plan. At 9:03 p.m., the flight will be 54 hours into the mission. However, under the nominal flight plan, the 54-hour mark should have been reached at 8:23. To correct this, the crew will move their mission elapsed time clock ahead 40 minutes to coincide with the real time clock.
This is by Francis Dodds, Austin. A bill creating an upper-level college at Clear Lake as a branch of the University of Houston has been approved by the Senate Education Committee. The bill, introduced by Senator Chet Brooks of Pasadena, would create the University of Houston Clear Lake campus primarily to serve 6 area junior colleges. The proposed 360-acre campus is adjacent to the Manned Spacecraft Center. The proposed college must be started immediately, Hoffman said, for 2 reasons. To be of service to San Jacinto Junior College, Alvin Junior College, Brassaport Junior College, Lee Junior College, College of the Mainland, and Galveston Community College, and to help limit enrollment at the University of Houston's main campus to 30,000. And then on later it says that the University of Houston Clear Lake would accept students with 56 or more semester hours and would offer degrees through the master's level.
That's pretty interesting news.
Yeah.
Rochester, New York. Brooks Robinson, outstanding player in the World Series with his glove and bat, was named Monday night as winner of the 21st Annual Hickok Professional Athlete of the Year Award. The 33-year-old third baseman of the baseball champion Baltimore Orioles won by a large margin over another veteran, 43-year-old George Blanda, quarterback of pro football's Oakland Raiders. Robinson, who hit .428 in the World Series and made a series of spectacular fielding plays in the 5-game triumph over the Cincinnati Reds, received 62 of the 146 first-place votes by a panel of sports writers and newscasters. And that winds up the news for this evening down here, this morning up there. Good night or morning, Bo.
I'm going home and have dinner.
Hey, thank you, guys. Still don't understand that bit about changing the time on the Apollo 14 crew. I can't figure out what those guys are doing with that.
good newscast. You know, you're pretty high in the ratings up here.
Okay, thank you. Appreciate it.
This is Apollo Control at 51 hours, 56 minutes. Helping out Capcom Bruce McCandless on reading the news there was astronaut Carol Bobko. And at the present time, Apollo 14 is traveling at a velocity of 3,002 feet per second, and we show the current altitude 162,934 nautical miles from Earth. This is Apollo Control at 52 hours, 2 minutes. We'll be coming up in the next few minutes on the Bistatic radar frequency check. This will be a check of the spacecraft communications frequencies on the unified S-band and the VHF in preparation for an experiment.
This is Houston. When you're configured in a suitable VHF mode for the S-170 Bistatic radar frequency check, give us a call, and then we'll secure the S-band uplink for about 5 minutes on you. There's no great rush involved in this.
Okay, we'll start configuring now and give you a call.
Roger.
The Bistatic radar experiment, which will be performed in lunar orbit, will utilize the spacecraft unified S-band and VHF transmitters to reflect radio signals off the surface of the moon. These will be received on Earth, and hopefully the...
We're configured as a flight plan in 52 hours. Standing by.
Roger, we're going to go ahead and secure our S-band uplink. We'll belay that 14. We're going to wait until your rotation in PTC brings us around to the point where we can utilize Omni Bravo for the frequency measurement. I'll give you a call just prior to our turning off the uplink.
Okay, Bruce. Houston 14, speaking of daylight saving time, our sun comes up very regularly, every 20 minutes.
Roger, we copy. That's probably not unreasonable for the small-sized planet you're in right now.
Ed Mitchell's last comment about the sun coming up every 20 minutes refers to the fact that the spacecraft is currently in its passive thermal control mode, where it's rotating at the rate of 3 revolutions per hour, or 1 revolution every 20 minutes.
Apollo 14, this is Houston. We're going to secure the S-band uplink for approximately 5 minutes at this time. If you need us for anything, just give us a call. We can still receive you. We still have TM, and we would bring the uplink back up. Over.
Roger, you're turning the S-band off now. Is that affirmed?
Roger, we are turning the uplink portion of the S-band off at the present time.
Okay.
Roger out. Apollo 14, this is Houston. How do you read?
You're loud and clear, Bruce. 14.
Roger, as you may gather, we have the uplink back up at this time. We'd like to remain in the existing VHF comm configuration until we give you another call, however. That'll be about 20 minutes from now. Over.
Okay, we're easy to get along with. We'll stand by in this configuration.
Roger out. Apollo Apollo 14, this is Houston, over.
Go ahead.
Roger, Ed. Down at the Cape, there's a Thor Delta with a NATO communications satellite on it that is about 1 minute and 40 seconds from ignition. If you're in such an attitude, you can view the Cape. You might try a P-22 and pick it up in the sextant. Latitude 28.5, longitude over 2, 45.5. I say again, 28.5 and 45.5. It's your option, over.
Okay, I don't think we're going to be around in time. Hal's looking at the Earth out with the 5 right now.
Okay, maybe you try the monocular, but that probably doesn't hold much hope.
Okay.
Yeah, he's got the monocular out now, and that's 28.5.
Roger, 28.5 latitude.
Those coordinates.
Latitude 28.5 and longitude over 2, 45.5.
Okay, 28.5, 45.5. We'll try it, and Al's looking with the monocular now.
Roger, longitude over 2 is negative 40.5, negative 40.5.
Okay, minus 40.5.
Okay, Stu, 3, 2, 1, ignition down at the Cape.
Okay, I didn't get the optics on. The Earth wasn't quite around. It just went out of the number 5 window just before you go.
All right, Roger, we thought we'd just send the info up in case you happen to be in a handy attitude. Apollo 14, this is Houston.
Go ahead.
Roger, Al, we thought you might be interested in knowing we have Dr. House down here at the surgeon's console for a few minutes watching the progress of the mission.
Good evening, William. Glad to have you aboard.
He's waving back.
Tell him everything's fine, Griff.
He rogers that.
We understand that Dr. House is the surgeon who performed the successful operation on Al Shepard's ear, which cleared up the inner ear problem and is allowing him to make this flight. This is Apollo Control at 52 hours, 47 minutes. Flight Dynamics Officer Dave Reed has just completed briefing the flight controllers here in the control center on the procedures that will be followed and the rationale for the clock update, which is scheduled to occur at about 54 hours, 45 minutes, at which time the clocks in the computer complex here will be reset ahead 40 minutes, essentially placing us back on the flight plan, both in terms of ground elapsed time and in terms of Central Standard Time. One of the finer points being considered at the moment is whether to update precisely 40 minutes or to update 40 minutes and 3 seconds, which is in fact the exact amount of time that was made up in the maneuver. In other words, the point at which the spacecraft crosses the 180-degree meridian. If we update 40 minutes and 3 seconds, we will be precisely on the GET at which that event will occur. And at the present time, the vote here in the control center as to whether to update 4003 or 4000 stands at 1-0 in favor of 4003, and we'll let you know how the polling progresses. For the most part, no one seems to have too much of an opinion. The reaction seems to be about the same as the reaction that came in from the post-flight evaluation team, which is going to have to sort out all of these numbers and make everything agree and see that nothing gets confused, and that reaction was something to the effect of, if you have to update, do it any way you see fit. One point that Dave Reed made was that precautions will be taken to see that, in addition to keeping people from getting confused by the update, to see that the computers are also not confused by the update. In describing the rationale for the update, Reed mentioned that the booster, the Saturn third stage, the S-IVB, is targeted to place the spacecraft at the moon at the proper sun time, regardless of the time that it lifts off from Earth, recognizing then that the liftoff time was 40 minutes late. The booster guidance system targeted a trajectory which was somewhat flatter, which arrived at the moon approximately 40 minutes earlier than it otherwise would have. And we're now in the process through this flight plan update, through the GET update rather, of making the clocks and the flight plan once again agree. And as I mentioned, once the update is carried out, the GET time on the clocks here in Mission Control will once again agree with the flight plan, and the times that are in the flight plan referenced to Central Standard Time will also be back in sync with the current Central Standard Time.
This is Houston. We've concluded the VHF measurements. You can turn VHF ranging, and the VHF switch is off.
Okay, thank you.
During the bistatic radar frequency check, which was just completed, the spacecraft VHF signal was being received by a 150-foot dish antenna at Stanford, and the spacecraft unified S-band signal was being received by the 210-foot dish at Goldstone, California. Reception of these signals will allow teams at these two receiving locations to get a frequency calibration, which will later be used during the period of orbital science when the bistatic radar experiment is performed from the command module. Basically, this experiment consists of reflecting the UHF and or the VHF and S-band signals off the surface of the moon, and when they're received back on Earth, certain conclusions can be reached about the dielectric characteristics of the lunar surface. At 52 hours, 59 minutes, Apollo 14 is 164,717 nautical miles from Earth, and the spacecraft velocity has now dropped below 3,000 feet per second. We're currently reading 2,954 feet per second.
Okay, Bruce, did you get the torquing angle?
That's affirmative, Stu. And do you have a time for us?
Hello, Houston, 14.
14, this is Houston, loud and clear. We have your torquing angles. Do you have the time for us? Apollo 14, Apollo 14, this is Houston. How do you read?
Okay, read you loud and clear. Bruce, did you have lockup? Did you get the torquing angles?
Roger, we've got the torquing angles. Do you have a time at which you torqued for us?
All right, that was 5-3 plus 1-1 plus 3-0.
Roger out. Apollo 14, this is Houston. We'd like to get battery Bravo on charge now, over.
Okay, will do. Battery Bravo.
This is Apollo Control at 53 hours, 58 minutes. We're now just about 45 minutes away from the scheduled updating of the clocks here in Mission Control. The flight plan calls for the GET update to occur at about 54 hours, 45 minutes. However, the precise timing of it is not critical, and it'll more than likely be done at some point when we're in communication with the crew, and when the timing is right as far as making the changes in the real-time computer complex. The flight dynamics officer has come up with a new set of coordinates for the predicted S-IVB impact on the moon. They are as follows: 8.4 degrees south and 25.9 degrees west, and the predicted ground elapsed time of impact is 82 hours, 37 minutes, 42 seconds. And of course that GET time will be updated by approximately 40 minutes. You'll be able to add about 40 minutes to that time to get the post-update ground elapsed time of impact. The update will be 40 minutes and 3 seconds. The straw vote that was taken in the control center turned out 1-0 in favor of 40 minutes 3 seconds as opposed to 40 minutes 00 seconds. The retrofire officer was the only one voting, and it was his preference that we do the update 40 minutes 03 seconds, which puts the flight plan precisely in synchronization with Greenwich Mean Time at that time. The things that were considered in making that choice, updating by 40 minutes and 3 seconds as opposed to 40 minutes and 0 seconds. In the one case, it makes the flight plan and the ground elapsed time perfectly in synchronization with no seconds left over. However, in updating 40 minutes and 3 seconds as opposed to 40 minutes and 0 seconds, it complicates computing back to get the real ground elapsed time. The difference, of course, relatively minor, and since the only one who really seemed to have a preference was the retrofire officer, Flight Director Milton Wendler decided to yield to that preference, and we'll update by 40 minutes and 03 seconds, adding that amount of time to the current ground elapsed time. We would like to repeat also an announcement that was made earlier, and that is that the television scheduled for the next shift at 4:08 Central Standard Time has been moved up 1 hour. This was done because of the deletion of the mid-course correction at mid-course correction 3 opportunity. That maneuver is not needed and will not be performed. In order to keep the LEM housekeeping activities all on the same shift, the flight plan was in effect condensed. Everything moved up an hour, and the television, which is associated with the LEM housekeeping, was also moved up, so that the current schedule for the TV is at 3:08 a.m. Tomorrow morning. At the present time, we show Apollo 14 traveling at a velocity of 2,906 feet per second, and the altitude is 166,487 nautical miles.
Apollo 14, this is Houston, over.
Go ahead.
14 Houston, I've got a string of pads here for you, starting off with a flight plan update, and then a little later a TFM update, and 2 maneuver pads. When you're ready to copy, let me know.
Roger, Bruce. Configured here. We're just finishing up on experiments. We'll be ready in a minute. ready to copy.
Roger, 14. On the flight plan update at 55 plus 40 PGET LOU, we'd like you to perform some more S-4B dim light photos while in PTC using P52 with the following noun 88 unit vectors. Now, stand by. Uh, 14, this is Houston. How do you read?
Okay, we're reading. Where?
Okay, did you copy any of that?
Yes, how do you read it? That's the first part we got.
Any of the flight plan update?
Negative.
Okay, how now, 14?
Okay, go ahead.
Beautiful. All right, flight plan update at 55 plus 40 PGET LOU. Perform S-4B dim light photos while in PTC using P52 with the following values for noun 88. R1 minus 47607 minus 79244 minus 38131. Camera procedures and film magazine will be identical to those for the Earth dark side photos. The S-4B should be visible in the sextant between roll angles of 078 degrees down to 005 degrees. Over.
Okay, at last time of 05540, we will again take the S-4B photograph in the P52 988 minus 47607 minus 79244 minus 38131 using camera, magazine, and Earth dark side photograph. The section roll angles, including 078 down to 005.
Roger, read back correct, and that 5540 time is the post-GET liftoff update time, and we're preparing to give you a liftoff time update now.
Understand, that's the new time.
Roger. 14 Houston, TFM update, over.
Go ahead.
Roger, TFM OID 03 00006. Identifier 04 35223. Identifier 05 16020. The delta in time is 40 minutes 02.9 seconds. Added to GET and subtracted for TFM. Over.
Okay, the TF update identifier 03 is 00006. Identifier 04 35223. Identifier 05 16020. Delta T 40 minutes 02.9 a second. Add to GET.
Houston, roger out. And I have a update to your liftoff plus 60 pad.
Okay, go ahead.
Okay, on P37 liftoff plus 60, 06000 5381 minus 165 11700. Over.
Roger, GETI is 06000 5381 minus 165 11700.
Read back correct. I have a change to the previously passed SPS GNN flyby pad P30 for you. Over.
Okay, go ahead.
Roger, a time of TIG noun 33 should be 077 39 minutes 3444 seconds. And down at the bottom of the pad, GET of 0.05 G should be 165 5228. And both of these last pads assume the GET update. Over.
Okay, now 33 of the LOI minus 5 is 077393444, and GET of 0.05 G is 1655228. The rest remains the same.
Roger, readback is correct. Uh, 14 Houston, we observe you're in POO. If you can give us accept, we will send you a state vector update to improve your pointing accuracy for the S-4B photography, and a liftoff time update to adjust the GET in accordance with the pads that we've passed you. Over.
Okay.
And 14, we're going to hold off a few minutes here on the uplink till we get a good antenna switch over, and it will be coming at you.
Roger, I understand.
The uplink that Capcom Bruce McCandless was referring to is the elapsed time update. That'll be uplinked via telemetry to the spacecraft clocks. And shortly after, we would expect the clocks here in Mission Control also to be updated.
In the metal composite specimen number 4 has been cooked and cooled and recorded.
Thanks a lot.
The guidance officer reports that he's ready now to uplink the revised elapsed time to the clocks on board the spacecraft. And guidance and retro report that we're now updated on board.
The uplink is completed. I expect you'll want to reset your mission timers.
Okay, we'll do that, and we'll also call 1706 so you can look at TFM.
Oh, okay, thank you.
And our telemetry data now shows the spacecraft command module computer clock to be reading 55:34:30. Once the update is completed here in the control center, we'll have one clock which will be designated GET and will be reading the updated ground elapsed time. Next to that, the clock designated TB5 will be reading the original or actual ground elapsed time. And of course, we'll lag 40 minutes, 3 seconds roughly behind the updated GET clock. And we've just had the clocks here in the control center updated. We're now on liftoff savings time.
Car 3, TFM for us. My update was 16020.
Okay, stand by. I'd be glad to.
This is Apollo Control. Our revised time now reading 55 hours, 46 minutes, 22 seconds. And those elapsed time updates were made at the following times: 54, 53, 30 on the spacecraft. And that command was uplinked by the guidance officer.
Go ahead.
Okay, I've got a few words on the TFM situation. Probably the most significant part of the whole discussion is that both values of TFM are correct. And the way that they arrive at this is as follows. The left-hand most digit of the octal representation of TFM is coded to include a sign. If you break the left-hand most digit down into the 3 binary bits, the first bit being 0 represents positive, the first bit being a 1 represents negative. In the value of TFM update on the pad, you'll notice that in the R3 load it was 16020, which is a positive 16020. In the value that you read out of the command module computer, you will notice that R2 was 1 least significant digit larger than the pad value, that is 35224. And R3, having the left-hand most digit of 5, was in reality equal to a minus 16017, which is then subtracted from the 1 digit larger value of R2. Does that make sense to you all? Over.
Affirmative. Would you want us to leave the load the same?
Roger. Either load is correct. The command module computer does not force a positive sign or a negative sign on the octal value, but accepts whatever it happens to come up with. So either load is correct. Over.
Okay, assuming we have no more updates, how would you like us to update the TFM end of the LEM? Using the 1706 values?
This is Houston. I'll catch you when signal strength comes back up.
Okay.
This is Houston.
Go ahead.
All right, you're back on the question of which set of TFM to load. You can load either one in a LEM. If you want a recommendation, we recommend the pad value, but either one would be satisfactory. Over.
Okay, we'll call 1706 when we make our load. Thank you.
Roger.
And Houston 14?
Go ahead, 14.
Okay, Bruce, we got something in the sextant with those angles. It could be the S-4B. It's right off to the edge in the sextant field of view and being tracked by the CMC on those angles. And I'll look at it again on the next pass and then take some pictures of it after that.
Okay, Stu, very good. Could you tell that the object was tumbling or anything like that, do you think?
I'm going to look at it again.
Roger. Uh, 14, this is Houston. For your information, The major tumble motion now has a period of 5 minutes and 46 seconds on the S-4B, over.
Okay, thank you.
This is Apollo Control at 56 hours, 9 minutes. Apollo 14 now 168,880 nautical miles from Earth, and the spacecraft velocity 2,842 feet per second. In mission control at this time, we're in the midst of a shift handover. The flight director on the shift coming on is Jerry Griffin, and the gold team of flight controllers, the capsule communicator, will be astronaut Fred Hayes. We are planning a change of shift briefing in the MSC News Center briefing room, and we estimate that that briefing will be ready to begin in about 15 minutes.
Houston 14.
Go ahead, 14.
Okay, yeah, you really got the S-4B bore-sighted with those angles. Now, the other cycle around, I picked up a star that's also in the field of view. And the S-4B is tumbling, and you can see it right at the start when it comes in on this one, and then it disappears, and it comes back in right toward the end. So we're definitely locked in, and with those pointing angles, it's got the S-4B right near the center of the sextant, and what I picked up the first time around evidently is a star, and it's over toward the edge of the field of view.
Okay, and I understand you're going to try to shoot it the next time around, huh?
Yeah, we'll try to get some pictures. I guess I'll try to, I think I'll look at it one more time and try to get a time frame or a roll angle where it's visible in the sextant, and then try to take the pictures at that time.
Okay, it sounds good. It isn't going to be going anywhere.
Okay. We'll be hanging around here for a while. Yeah.
Houston 14.
Go ahead, 14.
I just wanted to say good morning, Fredo. I haven't talked to you today.
Yeah, good morning. I didn't quite good morning yet.
Houston 14.
Go ahead, Ed.
Hey, Fredo, remember yesterday I was talking about the oil canning effect of the heat contracting and the heating and cooling of these panels?
Roger.
And remember you said it looked like the same thing that was happening to LIM 7?
That's firm.
Okay, just wanted to let you know that I think our oil can wrinkles are prettier than LIM 7's oil can wrinkles.
Okay.
This is Apollo Control, 56 hours, 32 minutes, ground elapsed time. Here in the control room, the Gold Team Flight Director, Jerry Griffin, is conferring with the various console engineers, finding out what items have to be covered during the next 8 hours of the shift. Each man goes red on the flight director's status board, and after he completes the conversation, the button goes green. The off-going flight director, Milton Wendler, is now en route to the Houston News Center for a change of shift press conference. He is accompanied by his flight dynamics officer, Dave Reed. The group should be at the News Center within about 10 minutes to begin the change of shift press conference. Apollo 14 now 169,565 nautical miles from Earth. Velocity 2,823 feet per second. At 56 hours, 34 minutes ground elapsed time. This is Apollo Control. This is Apollo Control. The change of shift press conference with the off-going flight director, Milton Wendler, is going to start momentarily in the small briefing room in the Apollo News Center, Houston. 56 hours, 40 minutes ground elapsed time. This is Apollo Control, out and accumulating tape until after the press conference. This is Apollo Control, 57 hours, 3 minutes ground elapsed time. We have about a minute and a half of accumulated air-to-ground voice tapes that were recorded during the change of shift press briefing, which is now finished. We'll play those tapes back. Meanwhile, Apollo 14 is now 170,374 nautical miles out from Earth. Velocity continuing to decrease, 2,802 feet per second. Let's listen to that minute and a half of tape and then rejoin the air-to-ground live for any conversation that might perchance develop between ground and Apollo 14. Let's roll the tape.
Houston 14.
Go ahead, 14.
Hey, Fred, just for curiosity's sake, how far away is the S-IVB?
Stand by, Sim. 14, Houston.
Go ahead.
Do you have any estimate of how far the S-IVB is away there, Stu?
Stand by one. Hey, Fred, Apollo 14.
Go ahead.
Okay, after looking through the optics and judging the size and its relative motion through the celestial sphere, I'd estimate it at 2,178 miles from us.
Well, you might replace a rendezvous radar yet. The number they gave me was 2,400 nautical miles, and it has an RDOT going away about 1 nautical mile a minute.
Okay.
This is Apollo Control. That completes the brief accumulated tape of the communication between Apollo 14 and the ground. We're back live now on the air-to-ground circuit, continuing to monitor as long as the crew is awake. At 57 hours, 6 minutes ground elapsed time, this is Apollo Control.
Apollo 14, Houston.
Go ahead, Houston.
Okay, did you verify the outset switch in GDC?
Okay, verify that, Houston.
All right, Jared. Apollo 14, Houston.
Go ahead, Houston.
Okay, if you can give us poo and accept, we'll pump up a CMC clock update.
Okay, you have poo and accept.
Apollo 14 Houston, the computer's yours.
Okay, thank you.
Houston.
Go ahead, Houston.
Okay, FAO would like to know about when Stu took the S-IVB pictures and how much you got remaining on that sequence camera mag.
Okay, just stand by one.
Okay, Fred, I took them sort of reverse order, that using pretty much the same procedure as that dim light. However, I think going to end up with streaks on the film because of, you know, the way the CMC tracks the optics. But at 57 hours even, I ran 2 seconds at 24 frames per second, 500ths, and then I took 1 frame at 1/60th for 20 seconds, 1 frame at 1/60th for 5. And then at 57:20, I took 1 frame at a 60th for 50 seconds and had to cut it off there. Couldn't get a full minute. And then ran off another strip, and I'm calling it 78% left on the magazine.
Okay, Stu, I copied all of that. Thank you.
Right.
Apollo 14 Houston.
Go ahead, Houston.
I got a little configuration change for you on panel 226. I'd like to get O2 tank 50-watt heater, number 3 main A open.
Okay, let's run that again now. It's O2, the 50-watt heater on O2 tank 2.
Negative. O2 3 main A. 3 main A, Stu. And the reason is they want to look at a couple of cycles with just 2 elements of the heaters gone rather than 3.
Okay, so on O2 tank 3, we pull the main A 50-watt heater.
That's firm. And we'll stay with that configuration through the evening so they can get at least 3 or 4 cycles on it.
Okay.
This is Apollo Control, 58 hours, 2 minutes ground elapsed time. Apollo 14, currently 171,932 nautical miles out from Earth. Velocity continuing to decelerate, now 2,761 feet per second. Current ground elapsed time for mid-course correction number 4, if it should indeed be performed, is 77 hours, 38 minutes, 24 seconds. RCS burn of about 3 feet per second. Current estimates on S-IVB impact. Time of 83 hours, 17 minutes, 45 seconds. Latitude 8.4361 south. Longitude 25.9365 west. Space Digital showing the calculated weight of the spacecraft, the docked weight of the CSM and Lunar Module, 97,143 pounds. Continuing to leave the air-ground circuit open At 58 hours, 3 minutes ground elapsed time, this is Apollo Control.
Uh, 14, Houston.
Go ahead.
Okay, there's a request from down here to run through a little 4-step exercise in having Al check his electro leads and see if we can find anything early here, so we got time to do something about it before y'all get around to the suiting up part of it. And I guess it's at Al's convenience in the next few hours whenever he thinks he can work it in, maybe.
Okay, Doc, we're finishing up lunch right now. Let Al take over and see what he wants to try to do.
Okay. All 14, Houston.
Go ahead, Houston.
Okay, we're ready to terminate charge on battery B.
Okay, set up.
Stand by one till we get a little better comm and hardly reaching up. Houston, how you read now?
Okay, read you loud and clear. This is Al. I understand you still having a problem with my sensors.
Negative, Al. The situation is you did have the problem for launch, and then it mysteriously went away. And what they'd like is a visual inspection of the gear to see if we have anything that looks abnormal that we might think about fixing at this time rather than wait till just before suit-up time, where we'd like to not fiddle with anything.
Well, I've checked all the sensors, Fredo. They all seem to be firmly in place. They don't appear to have moved. I did have some garble in the Cobra cable at one time, and that has been changed. I'm now using the spare Cobra cable. That might have made the difference. I can switch back to that and take a check on that one if you want to.
No, I don't think that's necessary. I might just tell you what they had in mind here and see if you kind of covered all of the places they wanted you to check. Around each of the electrodes, they wanted to know if you had any of the paste that appeared to leak out that you could see stain under the large round pieces of tape you got over them. That was the first item. Then another inspection thing was to look at the solder joints. That's the areas that have the little plastic sleeves over them, to see if you could see anything that appeared to be cracked or coming loose in there. And I guess the last inspection item was in your bio belt to check that the top and bottom connectors on the little blue EKG signal conditioner was all tight.
Okay, we had one that appears to have leaked a little bit. It's the bottom one on the sternum.
Okay, the bottom one on sternum. Okay, and I guess the only other square, which would be pretty easy to fill here, Al, is looking at your data now, is to sequentially put some firm pressure on each of the three sensors for about 10 seconds, giving a call down when you're applying the pressure.
Okay, I understand you're ready now?
That's firm. They're looking at your data now.
Okay, in the top sensors in the sternum, I'm pressing down the one closest to the right shoulder now.
Okay.
And I'm releasing on that one now.
Okay.
On the top of the sternum, pressing down the center one now.
Roger, Al.
And releasing now.
Okay.
Okay, on the bottom of the sternum, the one that appears to have leaked a little bit, I'm pressing down now.
Okay.
And releasing now.
Roger.
Okay, that takes care of the three.
Okay, I think that fills all the items I got here, Al.
Okay, this is Al. You can understand that we're cleared to continue on the present harness and cable configuration.
Yeah, for the time being, that's the word, Al, but they're going to look at the data. I guess the bottom one you pushed on showed more change than the others, and they're going to look at it a while and decide if they want to do anything about that bottom one, I guess.
Okay. Houston 14.
14, Houston. Houston, I can barely make you out there. Go ahead. Okay, 14, Houston, you should be all right now. Go ahead.
Okay, Fredo, inquiring about the LIM command module Delta P test at 59 hours. That number 2.7 still good since we have already been in the LIM and had a problem with our probe.
Stand by one. 14 Houston, the answer is the 2.7 number is a good one.
Roger, roger.
Apollo 14, we have the null bias check if you raise copy.
Okay, go ahead, Al.
Okay, at the end of 100 seconds, it was reading minus 9er, 8.9er.
Okay.
This is Apollo Control. 59 hours, 10 minutes ground elapsed time. Most recent conversation, a very brief exchange some moments ago about some spurious signals or at any rate some problems with is one of the sensors on Spacecraft Commander Shepard's Biomedical harness, and they wanted to get the problem sorted out prior to the time the crew suited up for the lunar landing. But apparently it's just some looseness in the sensor, and the surgeon is toying with the idea of perhaps having him put some additional paste underneath the sensor and another piece of tape. This will be resolved at some later time. Here in the control room, the spacecraft communicators are having a separate handover from the rest of the flight control team. Apollo 14 backup lunar module pilot Joe Engel is replacing Fred Hayes at the Capcom's console. Apollo 14 now 173,754 nautical miles out from Earth. Velocity 2,712 feet per second. At 59 hours, 12 minutes ground elapsed time. Still up live on air to ground. And looking at a TV pass to begin later in the morning as the crew begins the housekeeping chores in the lunar module. This is Apollo Control.
Houston 1402 heaters configured per flight plan.
Roger.
Apollo 14, Houston.
Go ahead, Houston.
Okay, Al, first we got some words for you on the replacing this lower ACG sensor, and it'll be just taking it off and cleaning it and replacing the same one.
Okay.
Okay, the materials that you're going to be needing are all in the medical kit over in R8, and what you'll need is one of those large pieces of tape and one of the rings that fit on the sensor, and the paste that's in the plastic bottle, and all these are in the kit.
Okay.
Okay, and you can do this at your convenience, Al. Just a couple of things that we want to make sure you get cautioned on. I'll go ahead and go through the procedures here, and if there's anything that you want gone over again, why just holler. First, remove the tape and the sensor, and clean your skin with one of the wet wipes, and then wipe the paste from the inside of the sensor. Wipe the sensor itself out first, and then pull off the old piece of tape. That's a double sticky back. It looks like that round double sticky back Scotch tape. Pull that off after you've cleaned the sensor out. Then take the new ring and pull off one of the pieces of cardboard on the ring and put it on and leave the other side covered. Then put the paste in the sensor. And after you've got the paste in there level, pull the other side off so that its sticky back is showing, and put it back on your skin then.
Okay, I understand. I'll give you a call if I have any questions. It sounds pretty good.
Okay.
14, Houston.
Go ahead.
Okay, we'd like you to put off doing the water dump in a little bit here. I'll have a flight plan update with some instructions to shoot some pictures when we have you do that.
Okay, you caught me just in time. I was on my way to the dump valve now.
Read your mind, Ed. Which dump
Okay,
was
did you
that?
get the torquing angles, Houston?
We got them.
Okay, I trust you're going to put it off until after we've finished with the lab and the TV show, etc. Is that right, Fredo?
Yeah, I think the pictures they're wanting from the limb side.
Okay.
time on that torquing was 59:41:10.
Okay, 59:41:10.
Raj.
14, Houston.
Go ahead.
Okay, I got flight plan update for you here, and a whole bunch of words on shooting the water from the limb.
Okay, go ahead. I'm ready for the flight plan update.
Okay, at 60 hours and 40 minutes, where you maneuvered a TV attitude, we need to change the roll angle to 069. And as a result of that, we also change the high gain angles to minus 66, pitch, and yaw 105.
Okay, Fred, I got the high gain angles of a minus 66 and 105, and say the new attitude for TV.
Okay, it's the only thing changed is the roll angle to 069, so it'll be 069, 090, 000.
069er, 090, 000, minus 66, 105.
Okay. Now, some words on the water dump. Like to delay the wastewater dump to 62 hours and 30 minutes, rather than the 59:50 that it had previously been set at.
Okay, I got it. Wastewater dump at 62:30, and say after that.
Okay, the after that was just to scratch out the 59:50 you had it before. Now some words on the camera operation. Al and Ed should take over to the limb with them, magazine F out of the B8 cushion, and borrow your 18mm lens out of the command module.
Okay, and now take magazine F out of B8, and I guess I'll let them borrow my 18mm to take in the limb.
Okay, you just might make sure they give it back to you, but when they get it over there, they can stick it on the limb deck and...
I'll have to sign a receipt.
Yeah. And put the following settings required on the limb deck then. F8. 1/250th, 11 feet, and 24 frames a second.
Okay, put the 18mm on the limb deck and set her up F8, 1/250th, 11 feet, and 24 frames per second.
Okay, and to run the camera, of course, they're going to need the sequence camera circuit breaker closed, and that actually fits in pretty well if they just do all this business right where that's called out on page 116, step 9 of the activation list.
Okay, they'll need the sequence camera circuit breaker in, and we're talking about page 116, step 9.
Right, and if that doesn't quite align with the flight plan time I give you, that 62:30, it isn't going to matter that much anyway.
Okay.
Okay, now they need a cue from you, Stu, to let them know when you're going to start the dump. And what they'd like them to do is have the camera pointing through the docking window of the limb, the upper window, right at the vent, and run it 20 seconds worth at 24 frames.
Okay, they'll bore sight on the vent and run her 20 seconds at 24 frames.
Okay, then they'd like to change the frame rate to 1 and run the camera for another 20 seconds.
Okay, change to 1 frame per second and run 20 seconds.
Okay, after that chore, they can rest a while and wait till you get down to the end of the water dump, Stu, and you can kind of give them the word when you're ready to shut her off. And then they'd like them to shoot the vent again at 24 frames a second for 10 seconds. Stand by one, Stu. We got pretty bad comm now. And Stu, how do you read me now?
Loud and clear, Fred.
Okay, we left off with them shooting 24 frames for 10 seconds when you turn the valve off.
That's affirmative.
Okay, then they're to change the frame rate to 1 frame per second and run the camera for at least 60 seconds or until cloud particles are no longer visible. But I guess if neither of those two events happen in that time, they're not to run it longer than about 180 seconds worth. In other words, they like to get a picture of the last drop there, Stu.
Okay, they'll change to 1 frame per second for at least 60 seconds or until no vent, and max time will be 180 seconds.
Yeah, that's it. Then the only thing else is you can frisk them when they get back and make sure they got your 18 millimeter lens and the mag-F back across, and they should put the 10 millimeter back on the limb camera.
Raj, I'm having Al sign a receipt for the command module property in here before it leaves.
Okay. And 14, we're going to have a site changeover here directly. We may lose you for a minute or so.
Okay.
And 14, Houston, radio check.
Loud and clear, Albie.
Okay, I guess we successfully did the switchover.
Houston 14.
Go ahead, Stu.
Okay, Fred, I'd like to question you here since we've had this change in the flight plan about going to the wide deadband here. If I do that, then it'll be another maneuver back to start the PTC, where if I stayed narrow deadband, I could be damping the rates when I got ready to start the PTC. Would you smoke that over there and see what you think about that?
Okay, stand by, Stu. Stand by 14 to get a little better count. Houston.
Go ahead, Houston.
Okay, I thought I heard you call a while ago.
Houston, you read 14?
Okay, I'm reading you about 3 by 3. Go ahead with your message.
Hello, Houston, do you read 14? Houston, do you read 14?
14, Houston.
Okay, Fred, we're reaching up to.
Okay, we got good signal strength again here.
Fred, I didn't hear back from you, and I wanted to get to the roll on this time around because it was going to be too late the next one, so I'm going to go ahead and go in the narrow deadband. Looks to me like would save gas that way.
Okay, he was still trying to crank out some numbers to compare there, Stu. How do you read now? Houston, how do you read? Houston, we're like Omni Alpha. And Houston 14, how do you read now?
Houston, this is 14, you're loud and clear.
Okay, the narrow deadband looks like it'll save you a little gas there, Stu.
Okay, I didn't hear back from you, so I wanted to catch the roll this time around, so I went ahead and went narrow.
Okay.
Houston, I'm on the high gain right now. How do you read?
Loud and clear, Ed.
How's your PCM?
Okay, they say it looks good.
Okay. Houston 14.
Go ahead, Ed.
At this high gain antenna setting, it will not switch over to narrow deadband apparently. I have as much signal strength at medium as I do in narrow.
Okay, we'll think about that. Okay, 14, Houston, I'd like you to stay in narrow.
Roger, that's where I am. Houston 14.
Go ahead.
Roger, we're in the process of pressurizing the limb now, as you can probably see. We're holding for the integrity check at this point. I have the television set up and can turn it on at your command.
Okay, Ed, stand by on the TV. We'll see if they're ready. Okay, they're all set up, Ed. You can turn on anytime.
Houston, I'm transmitting.
Okay, we got the picture, Ed.
Roger, you should be able to recognize it. There's the commander's number 1 window is in field of view at the moment. And Alan is up in the tunnel working the pressurization procedure. Stewart is coming up under the the commander's seat. You can see his head starting to come into the field of view now from stowing items down into the seat. See if I can get a little better picture here for you.
Yeah, Stu's head looks pretty good in color there.
You mean that color wheel can handle red, Fredo?
Yeah, it seems to be doing a pretty good job there. I noticed some speckles on the window there. Is that, did y'all end up with a little debris on there?
We have a few ice crystals, apparently, that have adhered to it from the various dumps we've made.
Yeah, Fredo, that window was clean as all get out till we started all the dumping.
At Houston, we're continuing the pressurization procedure. We've just opened up the pressurization valve between the two spacecraft. And we're flowing into the limb from the command module. Give you a picture if you can see it here. There's our cabin pressure gauge. Shows your quantity as well. Let's see if I can get it in view.
A little dark and out of focus there right now, Ed.
Yeah, it's a little too close.
Yeah, that's a little better. I can now see the your little card there showing the antenna patterns. But the needles on the gauges are a little hard to read.
We'll give up on that, Fredo. Our pressure is equal between the command module and the limb, and we will start removing tunnel hardware at this point.
Okay.
At Houston, we're starting to shoot up into the tunnel here where Alan Shepard is starting to pull the hatch out. If I can get him to look down for a minute and say hello to the world.
Okay, Ed, I can see a form there that I guess is Al. Its picture's just a little bit dark. You can see the lights up in the tunnel.
Roger. I think we'll have just a little bit more light when this hatch gets out of the way. We have all of our floodlights on full right now. While they're doing that, let's slide out to the CDR's window and take a look at the moon, which happens to be right out the window. approach this.
Okay. We can see it now. It's right down in the lower right quadrant of the window. The picture, though we send, is a crescent, and it's really not showing too much of the detail, Ed. Okay, I assume you're zooming the camera now, Ed, and we lost the picture of the moon.
Okay, let me try it again.
Okay, I think what happened when you zoomed, Ed, you ended up pointing above it.
See anything now, Madam?
Okay, it just disappeared out the lower right corner. We headed there for a little while.
Okay, how now?
Okay, there it barely came in the bottom portion of the picture now. Whereabouts is the terminator now? Is that about tranquility, somewhere in there?
It's past tranquility, and I think it's approaching zero longitude at this point, I believe.
Okay.
A few hours ago, it was just past Alpha Technius, Fred.
Yeah, right, Stu.
Right, I was looking through the section a minute ago at all of the cart, around the cart, and the Highlands showed up real well, and Terminator had just moved on over just past Klein.
Okay, and for your information, and the audience in the back here, we have most of the family in tonight, or this morning down here, I should say.
Yeah, 3:15 is a good time of night to have a TV show.
Prime time. Yeah, that's about right in the center of the picture now.
Okay, I've got full zoom on it, Fredo, and maybe it's too bright. Let's see if I can darken it and improve the picture a little.
Yeah, you're right. It's so bright, Ed, we have the crescent, but not too much detail there. Yeah, that's a little better.
And from our point of view, the moon appears about the size of a grapefruit fruit held at the arm's length. Starting to get considerably bigger, and don't have the Earth to compare it with at the moment, but I suspect they're about the same size, or maybe the moon is starting to exceed the Earth in apparent size.
Okay, and the big board now has you at about 180,000 out.
Roger. Okay, I'm going to come back inside. We have now stowed the hatch, and Stu and Al are up starting to bring the probe out. And very soon we'll be able to make a trip into the limb with the camera and see what we can find in there. We have not, as you can obviously see, rehearsed this. Our procedures are new to us going into the limb for the first time. And as a matter of fact, we were a little bit rushed getting the be ready here in about 2 minutes to move on into the LAM, I think.
Okay, Ed.
And now let's go back inside the command module.
Okay, are we looking up in the tunnel area now, Ed? It's pretty dark right now.
Yeah, I'll be bringing the probe out.
Yeah, I'm trying to, Fred, but it's dark. Just 1 second, I'll see if I can improve the light situation for us.
Roger.
Okay, you're looking directly up into the tunnel now. The probe has been released from the drogue and still we're bringing it straight down through the tunnel.
Yeah, we got that picture in pretty good now. We can see it coming on down.
Okay, Houston, Alan, Stewart taking the probe down under the right-hand couch now.
Roger, Ed. Yeah, we can see Al in the picture now.
Okay, it's probably clearer for you than the ears on my monitor. It's a little dark in here. You can look up the tunnel and see the drogue you have for internet, and I'll go up and pick it up for you. Okay, you're looking directly at the drogue now, which is gray in color and which has a hole in the center for the capture latch.
And our color picture here, the opening in the drogue looks red in color, like a big red eye.
Okay, and Alan has it out. He's starting to come down the tunnel with it. It's probably a little dark for you, but it's coming down anyhow.
Okay, and we've temporarily, I hope, lost our picture down here, Ed.
Okay. do you have your picture back yet?
Negative, Ed. And 14, the problem with the loss of picture is on our end of the street.
Okay. Tell me when you have it back and we're ready to go through into the limb.
Okay. And Ed Houston, you may continue the commentary. I guess it's being received out at the site and being recorded. We're just not getting it in plumbed into here.
Okay. Well, we were just holding up here. Alan has slipped on through into the limb and is opening up the window shades, turning on the lights so that as we go in, we will have some lights to give you a little better picture. I'm waiting here to get your picture back before I start in. However you would like, I'll go ahead and go into the limb.
Stand by, Leonard. Okay, Ed, they don't have an estimate right now. We might wait a couple of minutes, and then I guess if we hadn't got it back, you can proceed.
Okay. Okay, Alan's going back through the tunnel now, and it'll be clear here in a minute. Houston, while we're waiting for your picture to come back, and since it is being recorded at the site, we will take a quick station break and let Alan give us a commercial for Apollo 14.
Okay.
Okay, Apollo 14 is progressing very nicely. As you can see, we're now right on schedule, and it looks like the first mid-course correction is going to put us in for the lunar orbit insertion burn very close to rest. We're currently preparing to go into the limb, as Ed has told you, and so far everything is working very well with the command module. We're very pleased with the way the systems are working. Everything ship here. Everyone is well. Everyone is resting well. We're adapting to weightlessness, I think, very rapidly. And everything is going along very smoothly at this point.
Roger, Al, and we have a picture back now. It's just a little bit on the dark side, but we can see you quite well.
Okay, Fredo, we'll start on in. Okay, how's that?
Hey, that's a good picture, Ed.
Okay, we're starting through the tunnel. Why don't you show the docking lights while you go by, Ed, see how they look on the television. Can you see the docking lights, Fredo?
Roger, we can see those, Ed. We can see on down through the tunnel and the top of the S and engine cover.
Okay, I think it's significant that in spite of our problem the other day, that when Stu finally got us into the docking ring, that all of them snapped shut, which was very well lined up. And our docking index, as you know, cost us a case of beer, I think, because it's within 1 degree.
Okay, and you might let us know, Ed, how you find the fit through the tunnel there.
Okay, I'm sliding through.
Hey, was that question from Joe?
I'm not sure you don't up to it.
Okay, I'm through the tunnel, and I'm right at the top of the limb. I'm showing a camera down on the main consoles on the commander's side. How's that picture, Fredo?
Okay, that looks very good, Ed.
And let's see, I'll turn it around. I'll go ahead and go on down and twist around, and maybe we can look out the window. Okay. And we're now inside the lip.
Roger, Ed.
Can you see that, Fred?
Yeah, we see what looks to be a patch there, Ed.
Is it good enough for you to read it?
Is it something like beep beep or?
How did you ever guess? Must be some prompting from the ground.
Okay, and Ed, a good portion of your swing here, the picture is a little bit on the dark side. You might try open it up just a little bit more.
Right, I've had it open all the way, Fredo.
Well, I guess you can't do any better than that. Did you find the limb pretty clean, Ed, when you first came aboard, or was anything loose in there?
spacecraft, Fredo, have been immaculate. I think we have found one washer floating along about 1 day ago, and we have seen nothing that was foreign to the spacecraft either before or since that time. And as I say that, I see one floating by me right now. It may be the same washer. Yeah, I'd like to point out, Ed's talking about something external to the spacecraft. The cabin of both the command module and the lab are extremely clean. We've been very pleased with the way they've looked.
Very good.
Yeah, I think from what we've heard along the line, we actually expected maybe to see a few more nuts and bolts. I think a lot of credit goes to the checkout crew and everything, because this spacecraft is really in good shape.
And Fredo, I'm passing the camera back into Alan in the command module. We don't have enough light in here to really give you a good picture, and there's not much help from the outside since the sun is behind us right now.
Roger, Ed. We got a pretty good picture of you down in the tunnel right now.
Hey, Fred, did you hear that last comment I made about the crew and how clean the spacecraft was?
Roger, Stu.
Well, that was planted, you know, for all the authorized people that worked on the spacecraft. You know, we're really inundated with unauthorized objects in both spacecraft. I think Ed was showing you one up there, but if you can see this, I don't know if any of the backup crew is down in there tonight or not, but okay, how about here? Is that, you know, that they've left their calling card.
Okay, we have a pretty good picture of that, Stu, and they are here.
Okay. Don, we sure appreciate every compartment that we open up, having one of these come floating out of it.
They aim to please.
Stu, you want to take the camera? Perhaps you can move it on out the window. I don't know how much light there is, but sure is a good shot of the moon out there. You might try again with a monitor so you can see what it looks like to them.
Well, we'll give it a go.
Okay, we can see the moon again in the number one window. It's down in the lower left corner now, Stu. Okay, that's about right in the center. Okay, that's picture is a little bit distorted now, Stu. A little bright.
Okay, that ought to help it a little.
Yeah, that's about right. It's still hard to see in this picture much in the way of detail of the features, any features on the surface. Right at the terminator we can pick up a few craters, but other than that, it's really hard to see very much.
Okay, yeah, I didn't think it was going to show up too much there, Fred, because that's really the way it looks with the eye. It's just now starting to, get into the area where the larger craters would show up.
Okay, we got a good picture of Al there now.
Okay, he's got the transfer items that he's taken up into the limb for the activation, and he might just give you a word on what they are.
The purpose of the excursion into the limb at this time is to check out some of the communications, do a little housekeeping, gently look the vehicle over, and also in this particular case we're going to take some pictures of the command module while we're there. This is done during the flight on the way to the moon to save time so that when we actually go into the limb for the final time prior to the descent, there will be less things to do. So I have a package of things here in my hand which I'll now be taking up into the limb, and we'll proceed on with our housekeeping tasks up there.
Okay, we can see you heading out with the package in hand there.
Okay, is there enough light up in there, Fred? You getting the picture?
Roger, Stan.
Okay.
Looks like running an obstacle course in the early going, getting by all the hoses.
You got it.
And Fredo, I'm starting back through the tunnel now to pick up the rest of the equipment. We have several 16 and 70 millimeter camera bags that are being transferred over. We'll pick those up and be right back with you.
Okay, Ed. Okay, I guess the picture I'm looking at now is you're pointing back into the LEB in the area where the optics would be. And I can see the radiation meter back there.
That's firmly, Fred. I'm just really trying to get the camera out of the way there for a minute. Ed's got the other film magazines. He's headed back up into the limb now.
Yeah, it fits through there quite easily. I guess zero-G really does help.
No comment.
and I are both in the lift now with all of our transfer items, and we'll proceed to go ahead and give us a checkout as per the timeline.
Roger that.
Okay, Fred, I'll try to move up here and maybe we can look over the shoulder a little bit.
Okay, I can see you moving back and forth. I guess you're headed down through now.
Okay, we're going to get a picture all up here, Fred. I'm up in by the limb hatch now trying to watch them work in the limb, but it doesn't look like it's going to be bright enough.
Yeah, it's a pretty dark picture now still.
Yeah, I'm afraid that's not going to show up. We had a little light. I guess we need a little sun through the limb windows.
Well, Houston, I guess Fred now will have to give you a show from that side. I mean, Stu now has to give you a show from that side. It's too dark over here. So I will press on this back.
Okay, and you're cutting in and out there.
Okay, how now? Is that better?
Okay, you're on clear now.
Fred, this is Al. As you know, we have the probe out. If anybody that is interested in taking a look at those, or you're pretty well satisfied that just taking still pictures of it from here on out will do the trick.
Okay, Al, the word is the pictures should suffice. They're not particularly interested in another look right now.
Okay, is there anything else you'd like to say before we sign off for the evening?
Okay, Ed, or Al, I guess the answer is no to your last question.
Okay. Well, in that case, we'll sign off from Apollo 14. We appreciate the opportunity to show you around the spacecraft and a little bit of the lamp, and I hope that next time you see the lamp, we'll have more light, so you'll be able to see it better.
Thank you very much.
This is Apollo Control at 61 hours, 23 minutes ground elapsed time. That ends about 42 minutes of television time from Apollo 14. Beginning of the LIM checkout of the lunar module, some of the housekeeping chores that the crew has to do, and for preparation of manning the LIM on landing day. The guests back in the viewing room for the TV transmission included B. Shepard, Mr. and Mrs. Alan B. Shepard Sr., Al's parents, his daughter, Mrs. Laura Snyder, a nephew, Bob Williams, Mrs. Shepard's mother, Mrs. Russell Brewer, and a friend of Mrs. Shepard, Mrs. Richard Abbott. Others in the viewing room were Mrs. Louise Mitchell, wife of the Lunar Module pilot, their daughters Carlin and Libby, and Ed's mother, Mrs. Ernest Wagoner. Stu Roos's wife, Joan, their children, Chris, Jack, Alan, and Rosemary.
Okay, Fredo, you want me to stay on the high gain here or go to Omni Charlie?
They would like you to stay on high gain.
Okay.
Okay, and Stu, would you pass one word on down to Al and Ed?
Yeah, I can do that.
Okay, would you tell them to give us a call before they proceed on page 1-15, where they're going to turn on the comm and get a go from us and make sure we've got good lock on the S-4B.
Roger, Fredo, I'm still on the comm. I understood.
Okay, and I guess when you get there, Ed, just check with us, and I'll make sure they're set up good on the IU before you press on.
Okay, Fredo. Huh?
This is Apollo Control, continuing with the roster of guests and parents who were in the viewing room during the television pass. Stu Rusa's parents, Mr. and Mrs. Dewey Rusa. Two of Stu Rusa's sisters, Mrs. Patty White and Mrs. Gloria Sessoms, and a close family friend, Mr. Bob Perkins. The Space Digital's display now showing distance and velocity reference to the moon, now showing 44,175 nautical miles out from the moon. Velocity toward the moon, 3,241 feet per second. At 61 hours, 27 minutes ground elapsed time. Still live on air ground during the checkout of the lunar module. This is Apollo Control.
Uh, 14 Houston, you still there?
It's affirmative, go ahead.
Just pretty quiet, just want to see if you're still around.
That's firm. Houston 14.
Go ahead, 14.
Okay, Fredo, I guess sitting here looking the next hour, we you originally said we're going to go into BTC at 6210. I don't know if that was before you came up with the wastewater dump or not. We don't really want to start that before the wastewater dump, do we?
That's right, Stu. The time, let's see, I show on the flight plan change here is 63:10. Established PTC. I'll recheck that semi.
Okay, you're right, Fredo. 63:10. Okay.
Okay, Stu, but in any case, you're right, not before the water dump.
Yeah, that was my mistake. I'd marked that in, and before I'd moved everything up an hour, and I've got it back over here in the right place, and I didn't mark it off. Thank you.
And 14, while we're talking about PTC, Stu, I'd like BD roll selected before you crank it up.
Okay, we use BD roll.
Houston.
Go ahead.
You got any idea, Stu, where they are in the good book, so we can maybe begin to be worrying about the IU business?
Stand by, I'll check. Okay, they're finishing up 111, Fredo.
Okay, 111.
Roger, Eds. Roger, both of them 37 volts, Ed.
That's firm.
14, how do you read Houston?
Region 5 square, Fredo.
Hey, sir, when you get a minute, I need a VHFA check. Okay.
Okay, and we'd like high taps on the limb.
Okay, high taps on the limb.
Okay, we're going to get them to him.
Okay, I guess we're reading Antares now, loud and clear.
Okay, and we're just about to start the water dump.
Too many of you speaking at once there. Say again, Antares.
Okay, I was just giving you an S-band check from Antares.
Roger. Loud and clear, and go ahead, Kitty Hawk.
Disregard, Rick.
Okay.
Okay, your first one is 20 seconds at 24 frames a second, then 20 seconds at 1 frame per second. Then when you get near the end, when you're going to shut it off, you want 10 seconds at 24 frames per second, and then 1 frame per second as it peters off.
That's correct, Ed, except they didn't want to run it any longer than 180 seconds, which is pretty close to 3 minutes.
Yeah, I've got it. Can you see it? Oh boy, what a snowstorm.
And Ed, our Antares, just a reminder, you're on SPA down voice backup now, so you're hot mic.
Roger, suspected that, thank you. We're holding up, Fredo, on our procedures till Al finishes getting the wastewater dump pictures.
Okay.
It probably does. Yeah. Houston, from the lab, this water dump looks like a snowstorm.
Yeah, that's the way I figured it'd look.
Fredo, are you getting your low bit rate? If so, I'll switch over to high.
Stand by one. Okay, Ed, it looks good here. Low bit rate, you can go to step 3.
Actually, there's a high bit rate.
we got high bit right now, Ed.
Roger, going step 4. Houston, how do you read Antares?
Okay, I read you loud and clear, Ed. And Antares, Houston, we're ready for step 5.
Roger. And Houston, step 5, how do you read Antares?
Okay, Antares, we're reading you loud and clear on low bit right now.
Roger, standing by.
Antares, Houston, we're ready for step 6 now.
Roger.
Antares, Houston, how do you read?
Okay, settle loud and clear, how be?
Okay, that's not bad at all. I'd say you're loud and clear also.
Roger.
Antares, Houston, we're ready for step 7 now.
Houston, how do you read Antares?
Okay, Antares, Houston, read you loud and clear.
Roger, Houston. Kitty Hawk Antares, how do you read VHFA?
Ed, how do you read on A?
Loud and clear, please.
Antares, Houston, we're ready for step 8 now.
Roger, Federal, stand by 1. Kitty Hawk Antares, how do you read VHFA now? Houston Antares, how do you read?
Antares, Houston, read you loud and clear.
Okay, I guess I'm ready for step 8 now.
Okay, you're go for step 8.
Okay, now. Roger, how do you read now?
Read you loud and clear, Ed. Okay, Ed, everything looks good down here.
Okay, Fredo, stand by. We're still having trouble with getting our VHF to check out.
Roger.
Gas, B simplex.
Okay, Howby. Kitty Hawk Antares, how do you read C? VHF B. Kitty Hawk Antares, how do you read VHF B? Kitty Hawk Antares, how do you read now?
Antares, Houston, we'd like a readout on bat 5 and 6 voltage.
Stand by, Houston.
Kitty Hawk, Houston, we're ready to dispense with the water dump now.
I've already shut it off, Fredo. I'm just coming back up.
Okay.
Kitty Hawk Antares, read you loud and clear.
Okay, you're 5 square. Let's try A.
Okay.
How do you read on A, Ed?
Kitty Hawk Antares, read you loud and clear on A. How read?
You're 5 square.
Okay, we check out finally. Houston Antares, bats 5 and 6 are reading 36.5 and 37 volts respectively.
Okay, copied, Antares.
Okay, Ed, can I turn, you want me to turn VHF off?
Houston Antares.
Go ahead, Antares.
We're going to skip the OPS checkout until Al gets through with his camera work, and I'm going ahead to the cloud deactivation. We'll pick the checkout out shortly.
Okay, that'll be all right.
Okay, Antares is going off the air for a couple of days.
Kitty Hawk, Houston.
Go ahead, Houston.
Is Ed still downstairs?
Yeah, they're both down there.
Okay.
We just transferred to Command Module Power. I'll be coming back out in a minute.
Roger. Antares, I got a question there. I was wondering if Ed recalls back on step 1 on comm activation, if he had to switch the antenna, S-band antenna switch. Was it already in aft, or did he move it to forward and then back to aft?
Okay, stand by. Okay, this is Antares talking to Kitty Hawk's transmitters. We found the S-band antenna switch in aft as check was called for, and he did not move it for step 1.
Roger.
This is Apollo Control at 63 hours, 8 minutes ground elapsed time. Presently, crew of Apollo 14, two of them that is, en route back to the command module, if indeed they're not already in with the tunnel closed. Change of shift handover taking place in the control room now, where Pete Frank's orange team is taking over from the gold team headed up by Flight Director Jerry Griffin. And we will have a change of shift press conference in the Houston News Center within the next half hour or so. Participant being said Jerry Griffin. And at 63 hours, 9 minutes ground elapsed time, this is Apollo Control.
Antares, Houston.
Okay, this is Antares. Go ahead.
Okay, Al, are you back in the Kitty Hawk now?
No, I'm still in Antares, but I'm using Kitty Hawk cable.
All right, Roger. The question is, we've got you back on Antares, back on command module power now, and they're showing about 2 amps high. And the question is, has the reconfiguration been complete as per the initial activation status chart for circuit breakers back on 1.3 and 1.4 yet?
That is affirmative per checklist.
Okay.
Houston, Antares.
Go ahead, Antares.
The LPS check is complete. The source pressure on the CDR is reading 6200. Source pressure on LMP is reading 6000.
Okay, copied, Al. CDR is 6200, LMP 6000.
That's Al Shepard talking to Fred Hayes here in Mission Control. Meanwhile, in Mission Control, we're pressing on with our handover between shifts. The orange team coming in now to replace the gold team. We're at 63 hours, 15 minutes into the flight. We presently show Apollo 14 traveling at a speed of 2,554 feet per second and at a distance away from Earth of 179,900 nautical miles. Continuing to monitor, this is Apollo Control, Houston.
Houston, Antares.
Go ahead, Antares.
We rechecked our circuit breaker configuration, and we found that EPS DC bus volts panel 11 was out. It is now in.
Roger. Antares, Houston, over.
Go ahead, Houston.
We're just looking through the checklist on page 1-18 under the 64-hour call out. It shows that EPS DC bus volt circuit breaker back open. It comes after you check the circuit breaker chart up at the top of the page. So I guess that DC bus volt should be open.
Okay, stand by one.
It's Apollo Control, Houston. Gordon Fullerton now on the Capcom position, replacing Fred Hayes. That was Fullerton speaking just now to Commander Al Shepard. We're at 63 hours, 26 minutes, Apollo 14, 180,184 nautical miles away from the Earth. and traveling at a speed of 2,546 feet per second. This is Apollo Control, Houston.
Houston, Antares.
Go ahead, Antares.
Okay, I think our checklist is finally in phase with your checklist, and the DC bus bolt circuit breaker panel 11 is out.
Roger, Al.
This is Apollo Control, Houston, 63 hours, 29 minutes. Participants for the change of shift news conference are presently en route. We anticipate the conference to start in approximately 10 minutes.
Apollo 14, Houston.
Go ahead.
That current to the LEM seems to be dropping down. It's down to about an amp now. It's looking pretty normal, so we don't think any more effort trying to find out the cause of it is worthwhile. Over.
Okay, as I say, I think we're finally in phase now. Last item we did was turn out the floodlights, which probably helped your situation. The LEM hatch is now closed, and both Ed and I are clear of it.
Roger. Apollo 14, Houston.
Go ahead.
Roger, if it's convenient to get to, we'd like to know how much of that magazine Foxtrot you use taking pictures of the water dump.
Okay, Al says he used 1/3 of the magazine.
Roger, Stu, 1/3.
Apollo Control, Houston, 63 hours, 37 minutes now into the flight. Al Shepard, Ed Mitchell back in Kitty Hawk now, presumably closing out the LEM hatch, and at some point installing the probe and drogue and command module hatch. We show Apollo 14 at 180,438 nautical miles and traveling at a speed of 2,540 feet per second. At 63 hours, 37 minutes into the flight, this is Apollo Control, Houston. This is Apollo Control, Houston, at 63 hours, 39 minutes ground elapsed time. The change of shift news conference is scheduled to start momentarily. At this point, we will take down the line and tape any conversations which might transpire. This is Apollo Control, Houston. This is Apollo Control, Houston, at 63 hours, 59 minutes ground elapsed time. We presently show Apollo 14 at a distance of 180,983 nautical miles away from Earth, traveling at a speed of 2,526 feet per second. Capcom Gordon Fullerton has had limited conversation with Apollo 14 since we had taken the line down for the change of shift conference. We will play that conversation back to you now.
Houston 14.
14, Houston, go ahead.
Okay, Gordon, I guess you're going to give me a call when it's okay for PTC, huh?
That's right. Stand by, we'll take a look and see how your rates look. Apollo 14, Houston, you look good now. You're clear to spin it up.
Okay, thank you.
Also, we'd like Omni Bravo, and you're clear to secure the high gain antenna. Roger, Bravo.
Apollo Control, as you heard, Capcom Fullerton talking both to Stu Rusa and Ed Mitchell. Apollo 14 has now returned to its slow rotation, the passive thermal control of the spacecraft, and the high-gain antenna has been secured. We're at 64 hours, 1 minute into the flight, back up live. This is Apollo Control, Houston.
Apollo 14, Houston, over.
Go ahead, Houston.
Roger, we're watching your PTC and it doesn't look too good. It's heading right on out of the box. We lost data just as you started to spin up with that antenna switchover. It was poor timing on our part, so we're not sure just how the start went, but for sure this one isn't going to work. So at your convenience, if you'll restart another or redamp the rates and stand by for our go for another startup, over.
Apollo Control, Houston, 64 hours, 15 minutes ground elapsed time. Gordon Fullerton advising Ed Mitchell that it's our consideration to reestablish the passive thermal control mode.
14, Houston.
Go ahead.
If you stop near a roll angle of either 0 or 180, that will give us better high bit rate to watch your rates.
Okay, Stu's coming up calm now.
Roger.
64 hours, 16 minutes ground elapsed time, 14 now 181,390 nautical miles away from Earth. Presently traveling at a velocity of 2,516 feet per second. This is Apollo Control, Houston.
Okay, Gordon, I'm up here. That one didn't take, huh?
No, it just headed right on out to the limit for some reason, Stu.
Okay, Gordon, how do you rate?
Loud and clear, Stu. Go ahead.
Okay, so that one didn't take, huh?
Negative. It went right straight on out toward the limit on our plot here. We didn't get a good readout of the initiation of it because we had the antenna switch over right at the time. I'll stand by till we get through this into the next Omni here.
Okay.
Stu, this is Houston. How do you read now?
Okay, you're loud and clear.
Okay, I mentioned to Ed, if you'll stop the roll near 0 or near 180, we'll have good antenna angle for high bit rate and can watch the rates that way.
Okay.
This is Apollo Control, Houston, at 64 hours, 48 minutes ground elapsed time. We presently show Apollo 14 at a distance of 182,151 nautical miles out from Earth and traveling at a speed of 2,496 feet per second. The crew of Apollo 14 presumably eating at the present time. They will establish the passive thermal control, or reestablish the passive thermal control following this morning's meal. We're at 64 hours, 48 minutes ground elapsed time, and this is Apollo Control, Houston.
Madrid, Comtech on net 1.
Roger, Madrid, it's Houston, Comtech. How do you read me?
Roger, I read you 5er.
Roger, you can go normal, thank you.
Apollo Control Houston, 65 hours, 3 minutes ground elapsed time. We now show Apollo 14 at a distance of 182,520 nautical miles, traveling at a speed of 2,487 feet per second. We'll continue to monitor for any conversation as it should come up between Capcom Gordon Fullerton here in Mission Control and members of the Apollo 14 crew. This is Apollo Control Houston.
Apollo 14, Houston, over.
Go ahead, Houston, 14.
Roger, as you're sitting there, your high gain is pretty well pointed at us. We'd like to bring it up to watch the start of this next attempt at PTC. Would you go to auto and then select high gain?
Gordon, looks like we got the high gain.
Roger, we have it.
That's Stu Russa aboard Apollo 14 talking to Capcom Gordon Fullerton.
Apollo 14, Houston, you have a go to start the spin up.
Okay, thank you.
Apollo Control Houston, 65 hours, 8 minutes ground elapsed time. Apollo 14, 182,644 nautical miles away from Earth. Presently traveling at a speed of 2,484 feet per second. That was Gordon Fullerton giving a go for a restart of the passive thermal control.
14, Houston.
Go ahead.
It looks to us like you might have missed one jet enabled, Delta 2, to have a roll couple.
Right, thank you, Gordon.
At 14, Houston, your rates are still good if you want to give her a start.
Okay, thank you.
Apollo 14, Houston, over.
Go ahead, Houston.
We're showing the O2 flow up a little bit to 8/10, and suggest you might look around at all the overboard drains, valves, and make sure they're tightly secured. Over.
Okay, thank you.
Houston, give us Omni Bravo, and you're clear to secure the high gain antenna.
Okay.
Apollo 14, Houston, over. We see that the cabin pressure, which was down to near 5, is back up to 5.1, and the flow rate is decreasing now. Does this help you, give you any clues as to what the problem might have been? Did you find any loose valves? Over.
Not as yet. We're having a problem with a sticky myrtle. We're working on that. That's quite a problem right now.
Roger, Al.
Apollo Control Houston, 65 hours, 24 minutes. Ground elapsed time, we presently show 14 at a distance of 183,025 nautical miles away from Earth, and traveling at a velocity of 2,475 feet per second.
Apollo 14, Houston, over. Roger, I have a short shopping list of items for you here. First of all, the state vector on board there is in good shape and no update will be required as scheduled at 66 hours.
Okay.
And it's looking like mid-course 4 will be about 3.5 feet per second, 3.5 feet per second. And one question on the lens, the 18 millimeter lens that you took over to use to take the pictures of the water dump, just to help us keep track of where things are. Did you bring that back and restow it in the command module? Over.
That's affirmative. Gordon, the lens is back and stowed in the command module, and I understand mid-course 4 will be about 3.2.
Stu, that's 3.5, but that's close enough as we can tell now. The PTC is looking good. It's hanging in there, and although maybe it's too early to predict, it looks like it's going to take this time. There's an O2 heater reconfiguration shown at 6510 in the flight plan to do, and the pre-sleep items on the checklist, and that's all we have before you retire for the day. Over.
Okay, we just about 10 minutes ago configured the heaters, and we're going to press into the pre-sleep here momentarily.
Roger.
It's Apollo Control Houston, 65 hours, 43 minutes into the flight. That was Capcom Gordon Fullerton talking to Command Module pilot Stu Rusa. The report he made indicated no alignment of the platform would be required before the start of the rest period. Also, the plots of the passive thermal control mode as displayed on the guidance and control officer's console here in Mission Control appear very favorable. Mid-course correction 4, Flight Dynamics advises presently looks like a 3.5 foot per second burn. This is presently scheduled at a ground elapsed time of 77 hours, 38 minutes. And we now show Apollo 14 at a distance of 183,490 nautical miles and traveling at a velocity of 2,463 feet per second. We're at 65 hours, 44 minutes ground elapsed time, and this is Apollo Control Houston. This is Apollo Control Houston at 65 hours, 55 minutes ground elapsed time. Apollo 14 now at a distance of 183,764 nautical miles away from the Earth. Velocity now showing 2,456 feet per second. The crew of Apollo 14 just about ready to start their rest period. We may or may not have further contact with them. We will stand by and continue to monitor. In the eventuality we do have contact with the crew prior to the start of their rest. We're at 65 hours, 56 minutes ground elapsed time, and this is Apollo Control, Houston.
Houston, were you calling? You're very weak. Over.
That's affirmative. Gordon, I'm ready for an e-memory dump. Can you take it, Syscom?
I'm reading you just barely, Stu. Stand by. I'll check if we can take the E-mod and this kind of antenna configuration. Stu, we're going to have to wait a couple minutes until a better antenna gets up.
Okay.
Apollo 14 Houston, we are ready at this time for the E-mod, over.
Okay, Houston, here it comes. Gordon, I've got some onboard readouts when you're ready.
Okay, go ahead.
Okay, battery C, 37.0. Pyro battery A, 37.4. Pyro battery B, 37.4. RCS, Able, 87. Baker, 87. Charlie, 85. Delta, 86.
Roger, Stu, we copied all those.
Gordon, for a crew status, we're on good shape and no medication.
Roger, Stu.
Apollo Control, Houston, 66 hours, 3 minutes ground elapsed time. We presently show Apollo 14 at an altitude of 183,948 nautical miles away from Earth. Presently traveling at 2,452 feet per second.
Houston.
Go ahead, Houston.
Looks like we got the dump complete. And one question from ECOM, with his data configuration right now, he can't really tell if you cycled all the cryo fans. He just wanted a confirmation that you had, over.
That's affirmative. The fans were cycled.
Okay, thank you.
Apollo Control, Houston, 66 hours, 6 minutes. Following that conversation between Capcom Gordon Fullerton and Command Module pilot Stu Russa, we expect the crew to start their rest period, the e-memory dump completed. Then this should close out our contact with the crew. We now show Apollo 14 at 184,033 nautical miles away from Earth and traveling at a speed of 2,450 feet per second. This is Apollo controlled Houston.
Houston 14 is signing off for the evening.
Roger, Al. Pleasant dreams to y'all.
Thank you.
Apollo Control Houston, that was Spacecraft Commander Al Shepard advising Mission Control in Houston that the crew of Apollo 14 was ready to get some sleep. We now show Apollo 14 at 184,292 nautical miles out from Earth. Velocity now reads 2,443 feet per second. Ground elapsed time presently 66 hours, 18 minutes. This is Apollo controlled Houston. This is Apollo Control Houston at 66 hours, 35 minutes now into the flight. Our displays in Mission Control show Apollo 14 at a distance of 184,700 nautical miles away from the Earth, traveling at a velocity of 2,433 feet per second. Since the crew of Apollo 14 has begun the flight plan sleep period, we will bring down the line at this time and pick up again if any conversation should transpire. We're at 66 hours, 36 minutes, ground elapsed time, and this is Apollo Control Houston. This is Apollo Control Houston, 67 hours, 7 minutes ground elapsed time. We expect Capcom Gordon Fullerton will place a call to the spacecraft. Here we're showing a high O2 flow rate, apparently, or most probably caused by a leak of one of the overboard vents. If this call is placed, Fullerton will ask one of the crew members to check all of the valves on board. There's some consideration that they might not be seated properly. The passive thermal control mode, however, is still very stable. We'll stand by and continue to monitor in the event that call is placed. The line is now up live. Since Apollo 14 passed through the lunar sphere of influence at 66 hours, 49 minutes, 4 seconds, our displays in Mission Control are now referenced to the moon. We show Apollo 14 presently 33,202 nautical miles away from the moon and traveling at a speed of 3,306 feet per second relative to the moon. We'll stand by and see if the call is placed to Apollo 14.
We've also noticed that the main regs have opened as a result, and your O2 flow has been steadily increasing. Last time we had high bit rate, it was about 0.4 of a pound per hour. The PTC is being disturbed, but it still is stable. We wanted to alert you to try to troubleshoot this leak before we drove the PTC out of bounds. What we'd like you to do is check all the overboard drain valves one at a time, and this time we would like to try to tie down precisely which valve is the guilty one, and so we'd like to, as you either tighten them or jiggle them or whatever you can think of to do to the valves, do each one individually and give us time to watch the flow rate and see if we can tie it down. Over.
Okay, stand by.
That's Ed Mitchell responding to that call-up.
Houston, the waste management dump valve is going to off at this point.
Roger.
Houston, Apollo 14.
14, Houston, go ahead.
Gordon, did you notice a step increase in the flow rate, or has it just been a gradually increasing thing over the last hour or so?
It has been a gradual increase. However, we've been watching the data after you told us you closed the waste management overboard drain, and we're seeing a drop down. That may be the culprit right there. Can you verify the configuration that you were in? Did you have the cap on the Myrtle with that closed and the waste management overboard drain open prior to our waking you up? Over.
Well, the waste management...
Apollo Control, Houston, we'll stand by while we're having a switching of antennas.
Apollo 14, Houston, over. Apollo 14, Houston, over.
Houston 14, go ahead.
Okay, Ed, we missed your answer to my question completely during the Omni switch over there. Over.
Roger, your last question about the configuration of the waste management drain of the Myrtle?
That's affirmative, that question.
Okay, the Myrtle, the waste management system had been in use several times in the last hour, and if you saw changes, probably fluctuating up and down, it was undoubtedly due to that system.
I see. You've used it several times.
That's affirmative.
That's since you signed off for the night, is that right?
That's affirmative. Right now the drain is closed, and it had been closed, reopened and closed at least twice since we signed off for the night.
Roger. Apollo 14, Houston.
Go ahead.
The O2 flow has dropped back down now. It's not come down it still appears that the main rigs are maybe flowing a little bit. What we'd suggest is that you use a direct O2 to pump the cabin back up to 5.7, and then go on back to sleep, and we'll try not to bother you. The PTC looks like it should hold okay for the sleep period of it.
Okay, Gordon, that's fine.
Apollo Control, Houston, 67 hours, 21 minutes, ground elapsed time. You heard that last conversation between Capcom Gordon Fullerton and Lunar Module pilot Ed Mitchell. It would appear that the use of the waste management system may have been the culprit in this case. We now show Apollo 14 at 32,766 nautical miles away from the moon and traveling at a speed of 3,309 feet per second. That speed relative to the moon. This is Apollo Control, Houston.
Houston, this is Al.
Houston, go ahead.
Hello, Houston, this is Al.
Roger, Al. We read you weak. Go ahead. Ed, this is Houston. Go ahead.
Hello, Houston. Apollo 14.
Apollo 14, Houston. Loud and clear now. Go ahead. Apollo 14.
Apollo 14, Judy.
Roger, Apollo 14 is Houston. You're loud and clear. Go ahead.
Okay, two items. First of all, Al's got a sensor replaced. He wanted the medics to take a look at it. And I've pumped the cabin up, shut off the direct O2, and my flow is down to 2 temps now.
Roger.
Okay, yeah, advise them we're still in low bit rate, and it'll be a few minutes or a few seconds here before we can get high bit rate.
14 Houston, we're going to have to wait till we rotate around to an antenna angle that we can get high bit rate before we can check that sensor, but we'll give you a call in a minute or two when we're ready.
Okay.
14 Houston, CDR's Biomed data looks very good, according to Dr. Berry himself.
Okay, I just changed the paste in the sensor and put a new sticky washer on. The electrode weight is the same.
Okay, they're willing to sign you up for a permanent job at doing that if you'd like to after the flight.
Well, we'll discuss it. Houston 14, if you're satisfied then I'll return my comm configuration to the sleep configuration.
Okay, let me take one quick check here. Well, I guess that's all we got. We'll say goodnight once again.
Thank you, Gordon.
67 hours, 30 minutes ground elapsed time. This is Apollo Control Houston. We show Apollo 14 at 32,470 nautical miles away from the moon, and now traveling at a speed of 3,311 feet per second relative to the moon. This is Apollo Control Houston at 68 hours, 4 minutes into the ground elapsed time. We presently show Apollo 14 at a distance of 31,392 nautical miles away from the moon and traveling at a speed of 3,321 feet per second relative to the moon. We've had no further conversation with the crew of Apollo 14 since they were awakened by Capcom Gordon Fullerton to check a high O2 flow rate. Presumably the crew, if not yet sleeping, shortly will be. We're at 68 hours, 5 minutes into the flight, and this is Apollo Control Houston. This is Apollo Control Houston at 63 hours, 33 minutes now into the flight of Apollo 14. We presently show Apollo 14 at a distance of 30,431 nautical miles away from the moon, now traveling at a velocity of 3,329 feet per second. We've had no communications with the crew since our last report. The crew now in its rest period, or in their rest period. Meanwhile, activity in mission control has been, conversations over the flight director's loop have been quite subdued. It's been mainly a scene where flight controllers are studying their displays, considering the activities that will lie ahead on the next shift. A test of one of the lunar module batteries by Spacecraft Commander Al Shepard and Ed Mitchell is being considered either at the time of LIM activation or before. Ascent battery number 5 has shown a reading of 0.3 of a volt low on the open circuit voltage. If the test is run, it would involve putting the LIM battery number 5, the one under question, on one of the buses for an independent or second reading off another transducer and provide a second data point. The present reading is taken from the battery transducer without any load. If the second reading indicates a shift in the signal conditioner, then it would indicate faulty instrumentation rather than a fault of the battery itself. We will stand by and continue to monitor this possibility and provide updates as they become available. We're at 68 hours, 35 minutes ground elapsed time, and this is Apollo Control Houston. This is Apollo Control Houston at 69 hours 9 minutes, now to the flight of Apollo 14. We presently show Apollo 14 at a distance of 29,256 nautical miles away from the moon, traveling at a velocity of 3,340 feet per second. We've had no communication with the crew of Apollo 14 since our last report. Our clock in mission control shows a projected wake-up time of 5 hours 50 minutes from this time. At this time, we will take down the release line and bring it back should we have contact with the crew, which is not presently anticipated. At 69 hours, 10 minutes ground elapsed time, this is Apollo Control Houston. This is Apollo Control Houston at 69 hours 47 minutes, now into the flight of Apollo 14. We presently show the Apollo 14 spacecraft at a distance of 27,999 nautical miles away from the moon, and traveling at a speed of 3,353 feet per second. We've had no contact with the crew, now well into their rest period since our last report. However, in Mission Control, Flight Director Pete Frank has been holding discussions with Mr. Sig Schulberg, Director of Flight Operations, and Mission Director Chet Lee and others about the LIM battery test being considered. This a test on LIM battery number 5, which had shown a low readout during the LIM housekeeping activities early this morning. Battery number 5's voltage reading, both on the ground and through crew readout, read 36.7 volts. The normal reading is 37 volts. The proposed test would aid in determining if this, in fact, is a fault of the battery or an instrumentation or sensor problem. It has not yet been decided when the test may be held, either at LIM activation or before. We're at 69 hours, 49 minutes ground elapsed time. We will shortly be undergoing a shift handover in Mission Control, and a change of shift news conference will be held between the hours of 12:30 and 1 o'clock. This is Apollo Control Houston.
This is Apollo Control at 70 hours 22 minutes. The crew still has a little over 4.5 hours remaining in this rest period. At the present time, we're in the process of completing the shift handover. Flight Director Milton Windler getting briefed by the off-going Flight Director Pete Frank. Windler will shortly be going around the room and checking on the mission status with each of his flight controllers, reviewing the status of the mission at this point. A change of shift news briefing is scheduled to occur in the main auditorium of Building 1 as soon as the shift handover is completed. Our best estimate on that at the present time would be about 15 minutes. At 1:30, a Skylab briefing is scheduled. That briefing, if the news conference runs long, will follow immediately after the change of shift news conference. And it will also be held in the main auditorium of Building 1. At the present time, we show Apollo 14 traveling at a velocity of 3,366 feet per second and 26,819 nautical miles from the moon. At 70 hours, 23 minutes, this is Apollo Control, Houston. This is Apollo Control at 73 hours, 12 minutes. We're still considering the possibility of having the crew re-enter the lunar module following their sleep period to run a test on the ascent battery, which is showing at last check a slightly below normal open circuit voltage. No decision has been made at this time as to whether or not that will be done ahead of the flight plan. If it is decided to run the check, it would most likely be performed following the mid-course correction 4 and before lunar orbit insertion. The mid-course correction 4 is currently scheduled at 77 hours, 38 minutes. The maneuver will be performed at this time anyway with the SPS, the Service Propulsion System engine. The current velocity change required appears to be about 3.6 feet per second. That could be performed with the Service Propulsion System using a minimum impulse burn of about 0.6 of a second. The crew has a little bit more than 1 hour, 45 minutes remaining in their rest period. We plan to let them sleep the full time if they so desire. Flight Director Milton Wendler checked with the Flight Activities Officer a short while ago to see if it would be possible to extend the sleep period if the crew is still sleeping at the end of the period. And the Flight Activities Officer replied that it appeared it would be possible to extend it by as much as about 30 minutes and still not run into any problems getting the mid-course correction performed on time. We have a videotape of last night's television of the Lunar Module Housekeeping, which we're prepared to replay at this time. The video replay will be in black and white in order to minimize wear on the tape heads of the color converter, and we'll play that videotape back at this time. This is Apollo Control at 74 hours, 12 minutes. We now have about 47 minutes remaining in the crew rest period. Around the flight director's console for the past 45 minutes or so, there have been a series of group discussions on the procedures that are being worked out for checking out the LEM ascent battery. Flight Director Milton Wendler advised the flight controllers of the progress of the discussions a short while ago. He said that at this time we still do not have a decision as to whether or not we'll attempt to get into the LEM and check out the battery, although he said we do appear to be moving in that direction. If the crew is advised to enter the LEM and run the test on the LEM battery, it would be done after mid-course correction 4, which is scheduled to occur at about 77 hours, 38 minutes. We would like to have the crew completed with activities in the lunar module and back in the command module by about 80 hours to allow adequate time for the lunar orbit insertion maneuver, which is scheduled to occur at about 82 hours, 38 minutes. At the present time, we show Apollo 14 traveling at a velocity of 3,487 feet per second, now 19,068 nautical miles from the moon. At 74 hours, 14 minutes, this is Apollo Control, Houston.